Hello, everyone. Good morning, good afternoon, good evening, depending on which part of the world you are right now. What's very interesting because we have a really international workshop, and unfortunately, we are not in Spain right now, but I think we can have a really nice interaction and a really nice workshop at a distance. So I'll do a very quick opening of the workshop with the goal of just welcoming you and saying a little bit about our program. And then we are going to go to our keynote. Uh, so just a quick overview of the program. We have our keynote with Paige very soon. Then we have our first session with 3 papers. And what we're going to do is to have a short presentation of each paper, around 10 minutes, and a quick discussion of each paper, 5 minutes. And then we have at the end of each session, open discussion slot of 20 minutes, where we can go back to any of the papers, or we can discuss open topics, related topics, anything related to bots and software engineering, or we can just expand a little bit each paper. The idea of this workshop is to be a little bit more informal. So that's why we moved back to Zoom. We were initially on Cloudar, but there we have very fixed, straight time slots. So sorry for the inconvenience of this change, last minute change. So the idea here is to have a lot of flexibility, is to discuss the topic. This is a really new topic that's growing a lot in practice. So I bet that we have a lot of to discuss. So that's the goal here. Then we have our second session with 4 more papers and open discussion again. Then we have another keynote and 3 more papers, and that would be the last session. We're going to have small breaks in between the sessions, so you can drink a coffee or do your bio break, anything like that. So for our keynotes, we have Paige that's already here. Thank you, Paige, for accepting our invitation to the keynote. And Claudio Pianes, that's from IBM Research. He will talk a little bit about chatbots. And that's interesting because he doesn't work on software engineering exactly, but he works a lot on chatbots. So the idea of inviting him is to bring some experience from another field to share the information with us so we can discuss and identify commonalities and share our experience. And Paige, of course, is from the community. She works on software engineering, so it'd be really good to have these 2 different perspectives of the topic. Some statistics, we received some 11 submissions, from which we accepted 9. So really nice papers that we received this year. And we also have an invited journal first presentation. In total, we had 33 reviews plus 26 comments. This is, as I mentioned before, it's a really international workshop. We received submissions from 15 different countries, what shows the interest in the area from different places. And also we have a PC with from 11 different countries. So the research community is really spread all over the world. As I mentioned, we have 10 minutes plus 5 of questions and answers, followed by this open slot where we are going to discuss anything that we want. This is, again, a very informal workshop where the goal is to bring together this community and explore the topic. So we want to have this discussion open. Okay, and how we're going to do the questions and answers? We ask you to post your question on the chat, and then we are going to go in order of appearance, and we are going to call out your name and ask you to ask again your question live, so the presenter or the keynote can answer it, and also see the chat for the question, but we also ask you to repeat that aloud. Okay, so just post first your question on the chat. And of course, if it's your face-to-face, we are going to have bathroom breaks and dinner and coffee break. We wish we could have that, but as we don't, we provide 10 minutes break in between sessions. We just ask you to come back after those breaks, not go away and go to whatever daily routine. I know that's very strong, pushed us out of the workshop. I had that experience on ICSI. Every break that I did, it was really hard to return. So we encourage you to return after the breaks. And the social media is very active. So if you post things, we have this tag and the Twitter account that you can follow. And thank you for the program committee for doing this nice work in selecting the papers. And as usual, we want to build this community. So if you are interested in joining the PC for next year, just drop us a message and we will contact you afterwards. If we are going to have another one, that's something that we're going to discuss at the end of the workshop, the future of this workshop and community. And that's a very exciting news. We are going to have a special issue on software bots, bots for software engineering on IEEE software. So start thinking about your submission. We just got the news that the special issue was accepted, so we don't have the call for papers yet. Actually, we have, but we're not. It's not anywhere. We're going to publish it very soon. So keep that in mind and prepare your submissions. So let's move to the paper presentations for the first session.
Hello everyone, my name is Samone Sadat and I'm presenting our work on impact of bots on the workflow of GitHub teams. When tasks are too large or too complex for a single individual, teams are beneficial. In modern workplaces, bots are becoming more common as teammates. Although bots are created with the purpose of improving productivity of human team members, it is crucial to study the impact of bots on dynamics of teams to ensure bots are not disrupting collaboration. Online environments that collect users' action data such as GitHub are ideal laboratories to study human-bot teaming. Analyzing temporal sequences of teams can be used to provide novel insights about dynamic nature of teams. In this research, we created event sequences of GitHub teams with bots and teams without bots and studied differences between sequences of these two types of teams. GitHub is a popular software repository and a collaborative development tool. Developers can submit their contributions to repositories and have discussions around the project. Ever-growing complexity of modern software engineering makes the automation of tasks imperative. Software bots are developed to improve productivity and workflow of developers. In their basic form, bots are interfaces that connect users and services, and in their more advanced form, bots may exploit data analysis or AI techniques. Bots support individual developers by automating routine tasks, helping developers stay in the flow, performing redundant tasks, and improving decision-making. Bots also support team cognition by improving situation awareness and enhanced communication. To study impact of bots on teams, we take a sequence mining perspective and answer these questions. Do sequence patterns exist that distinguish human bot teams from human-only ones? How do bots affect the team sequence patterns? There are different types of patterns in sequences. Substrings are exact contiguous matches. Sequential patterns are exact in contiguous matches, and motifs are inexact contiguous matches. Since we are dealing with long sequences of human behavior, motifs seems the best type of pattern to consider as they are flexible and suitable for long sequences. We use a method called contrast motif discovery to compare groups of sequences. Assuming there are two groups of sequences, contrast motif discovery first finds candidate motif for each group and then discovers contrast motifs that are significantly closer to one group compared to other. The data we used for our research is 1 month of data on GHTorrent. We found over 45 million public events in this data, and we had 400,000 active users in this dataset. The first step to study bots is to identify them. We developed an automatic bot detection approach for this purpose. We prepared our training data by first finding all accounts that have the word bot in their username, and then manually labeled a subset of these accounts based on their GitHub profile and our web search. In 612 accounts that we looked at, we found 424 bots. Then we extracted features for all these accounts. Our features are comment similarity, which is the average cosine similarity of comments in that account. Organization owned, which shows if the account belongs to an organization. Unique event type, which is the number of types of event the account performed. And bot placement, which is the placement of word bot in the username. We trained and tested various classifiers on the labeled dataset, including logistic regression, random forest, and gradient boosting. We evaluated the classifiers using cross-validation, and since the dataset is imbalanced, we used stratified k-fold cross-validator. All tested classifiers achieved F1 score higher than 0.9. Gradient boosting achieved the highest F1 score of 0.93. We used gradient boosting classifier to build a model on 612 labeled samples, and we labeled the remaining unlabeled accounts. We considered a GitHub user team member if they contributed at least one push or one pull request event to the repository. A team is a repository with 2 or more human members. We removed non-members and bot events from the event log. Then we ordered the events corresponding to each team based on the time that event is performed, and created event sequences for each team. Following table shows the percent of different event types. Push and pull requests are most frequent events. These two events are used to submit changes made on a local repository to the main repository. To clean our dataset, we removed the least frequent events to make the algorithm run faster, and we combined issue and issue comment event as they are referring to the same kind of activity. We also removed sequences shorter than 5. Our dataset is imbalanced with about 200,000 human-only teams and 4,000 human bot teams. For each team, we created a vector that contains the frequency of the different event types in that team. Then for each human bot team, we found the most similar human-only team with respect to their event frequency vector, and downsampled human-only teams to 4,000 teams corresponding to 4,000 human bot teams. This table shows the median of event frequencies. The first column is related to human bot teams, the second column is related to original human-only teams, and the last column is related to downsampled human-only teams. And you see that after the downsampling, the medians of human-only teams are more similar to human bot teams. We ran the contrast motif discovery tool on the sequences we created for GitHub teams. These graphs show the contrast motifs for each team type. We observed a more complex graph structure for human bot teams, while human-only teams have a simpler structure. Another observation is that in human bot teams, issue comments occur before and after each event type. We hypothesized that this pattern occurs because in human bot teams, issue comments are intermixed with other events rather than being clustered together. To confirm this hypothesis, we measured the average length of consecutive issue comment events in all sequences. We ran a man-Whitney U test to investigate whether there is a difference between two types of teams. U-test indicates that the average length of consecutive issue comment event in human-only teams is higher than this value in human bot teams, and the difference is statistically significant. Literature shows that when automation is introduced to a team, humans lose situation awareness. Human team members may use comments to stay in the loop as a mechanism to gain situation awareness in GitHub teams. In conclusion, both human-only and human bot teams have contrast motifs that are found predominantly in only one of the groups. And the contrast motifs indicate that in human bot teams, issue comments are scattered throughout the event sequences, while in human-only teams, the contrast motifs are simpler and issue comments tend to be clustered together. It is crucial to further study the performance of human bot teams to ensure that continuous communication compensates for the loss of situation awareness and does not negatively impact the performance of the teams. Thank you for listening to our presentation. Now we would be happy to answer any question that you may have.
Okay, thank you. So someone else is here. Tom has a question.
Yeah. So it was a question related to the way in which you have identified bots in your data set. So on the slides, I have read that you found bot accounts and identified them by looking at the bot word in the usernames. But well, based on our own experience, we found that this leads to both false positives and false negatives. And I wanted to know to which extent this also happened in your case, if you have any feedback on this. More specifically, so you can have false positives because you may have bots that do not have, oh, not false negatives. You may have false negatives because you may have bots that don't have bot in their username. And in another way, you might also have real users, real humans that have bots in their username. We found actual cases of both. So I wanted to know if you have any experience with this, any feedback on this. If this was the case, how might it have slightly affected your results?
Yeah, that's a great question. Actually, yeah, I understand that there are some accounts that are bots, but they don't have any bot in their username, and our method misses those accounts. But with the classification that we did, we tried to remove the accounts that have bots in their username, but they are not bots. That's what we try to do with our classification method. So it's not perfect, but that's the best that we could do with this data set and resources that we have.
Okay, and the username was based on just the GitHub account, or
yeah,
or did you use some other username?
Their GitHub username, but to verify if they are bot or not, we looked at their profile manually and did some web searches to identify if they have bot in their username. We wanted to make sure that they are really bots, so we did some research to figure that out.
Okay, thanks.
Sure.
I have a question. You showed that it changes the workflow after the adoption of a bot.
Yeah.
Did you look for other factors that may have been introduced together with the bot that can cause this effect, like confounded variables?
We did not look at other factors. We were just looking at the sequences, and we wanted to see how the patterns are changed. Yeah, we did not look at other things that could cause this pattern behavior, but that could be a great future work for us.
Perfect.
Yeah.
Okay, if you don't have any more questions, remember that we're going to have the open discussion at the end of the session. So let's move to the second paper.
Wow, this has to be the saddest video intro you've ever seen at a virtual conference. A bot creates a pull request, which is then rejected after waiting for days or even weeks. Sure, some would say it's just a bot. It doesn't have any feelings, don't make such a drama out of it. But let me make one thing clear. The drama here is not that a single bot's feelings are hurt. The drama is that bots are systemically disadvantaged when creating pull requests. Longer processing times, lower acceptance rates, and we are talking about bots that developers consider useful and that are expected to have a positive effect.
Show me a single study that proves that such a bias exists in the interaction with bot pull requests.
I'm glad you are asking, because that's exactly what we did in our study. We compared the project maintainer's interaction with manually created pull requests to the interaction with automatically created pull requests. Kind of human versus bot, who do we accept more, is there a difference at all? Before I go into the details of our study, let me tell you the story that motivated this work. In 2019, a team of researchers conducted a study with a student development team. A new team member was introduced. It was a bot that automatically improved the code quality by creating pull requests. The students worked with the bot for around 40 days, and at first, everything seemed to go as expected. The team members found the bot great and useful. They were all like, yeah, we don't want to miss it in future projects. It helps us do the extremely valuable work that the other team members don't have time for. At the same time, the researchers noticed that only very few team members felt responsible for the bot. You might ask, why? It was mainly because the bot did not have the ability to push the other team members to review its pull requests, something the human team members often did to find a reviewer for their own changes. As a result, the full potential of the bot was not exploited, and fewer code smells were removed from the code than would have been possible without much additional effort. The end. Now, since this was a case study, we could not be sure if the finding was solely indicative of a problem with this student team and with this particular bot, or if there was a systemic issue where bots are disadvantaged in a project by their limited abilities, and maybe also by a potential lack of social pressure to engage with the contributing bot. Most would probably agree that making a human contributor wait feels different than ignoring a bot. For these reasons, we aim to complement the findings from the qualitative study that I just described with a quantitative investigation. Our research question was, how does maintainer interaction with pull requests differ between manually and automatically created pull requests? To answer this question, we conducted a GitHub mining study, and the whole process can be broken down into 4 steps. We start by defining criteria according to which the interaction should be compared. Then we find a dataset that contains many pull requests from real-world open source projects. In this dataset, we now have to identify all the bots, and then we can compare the pull requests of the bots with those of humans based on the previously defined criteria. Sounds simple, right? The comparison criteria were selected based on the assumption that pull requests by bots would be accepted less frequently and processed more slowly. Therefore, we considered the following 4 proxy variables for maintainer interaction in terms of acceptance and interaction effort with a pull request: acceptance rates, time until first human interaction, time until merged by human, and number of comments by humans. We use GitHub Torrent as data source and limited the dataset to entries from January 2019 to June 2020. That's 1.5 years of data and corresponds to more than 20 million unique pull requests. Bots were detected using a combination of several methods. Mainly, bots can be identified by their name, activity, or account status on GitHub. One then combines automatic detection with manual inspection, and existing datasets of known bots from other studies finally help to further enhance the list. So at this point, we had a large dataset in which we identified the pull requests that came from bots. Now it's getting exciting. Let's have a look at the data. Our dataset consisted of more than 20 million pull requests. The interesting bit is that around 1.8 million human user accounts are responsible for about 2/3 of these pull requests, while less than 5,000 bots created the remaining 1/3 of pull requests. Further, we see that pull requests from bots are smaller. Bots add an average of 673 lines and delete 343 lines, while humans add an average of 4,280 lines and delete around 1,800. Here you see the top 12 bot accounts by number of pull requests. A large part of all pull requests deals with the update of dependencies, and this should definitely be kept in mind when looking at the results in the following. For the human contributions with which we compare the pull requests, the variety of content is of course much greater. Humans not only update dependencies and fix a bug, but also sometimes add a new feature. So far so good. These numbers show that already today a huge amount of pull requests come from bots, although there are way less bot accounts than human contributors. To answer our research question, we now have to check if there are any differences in the maintainer's interaction with these two categories of pull requests. As I said, this is a quantitative study, so what follows are some plain numbers for the moment, and afterwards we will discuss what they might imply. First, pull requests from humans were merged in 72% of the time, while pull requests from bots were merged in 37% of cases. These numbers are regardless of whether human or bot merged the pull request. The average time it takes humans to merge a pull request by another human is only 14 minutes, but it takes a human more than 10 hours on average to merge a bot pull request. Interestingly, looking at how long it takes for bots to merge pull requests, it is the other way around. Bots merge pull requests of other bots after only 12 seconds, while human pull requests got merged after an average of 5.4 hours. Next, we looked at the interaction via comments, and we only looked at comments by human users. 23% of pull requests by humans receive comments by other humans, while other 2.2% of bot pull requests receive any comments by humans. The absolute number of comments that pull requests receive is relatively low for both types of authors, so there is a significant difference here as well, but not a substantially one in terms of effect size. Human pull requests receive an average of 2.52 comments, and bot pull requests receive 0.06 comments on average. Finally, one last comparison criteria was the average time until first interaction. We defined it as the time it takes a human to respond to the pull request for the first time, either in the form of a comment or by accepting or rejecting it. And here again we see a significant difference. It takes an average of 30 minutes from pull request creation to the first interaction with a human pull request, whereas it takes 12.3 hours for a human to respond to a bot pull request. An interesting observation was that the maximum time it took a human to comment on a bot pull request, excluding outliers, was 12.5 days. The maximum time for a human pull request to receive a comment was about 9 times smaller, at about 1.5 days. Whew, so many numbers. Let's summarize what's going on. Bots have a significant share in the amount of GitHub pull requests. Unfortunately, only a third of all bot pull requests are accepted, and these take longer to process than human pull requests. Whether it takes an average of 40 minutes or 10 hours to accept a pull request might not be decisive in most cases. But combined with the observation that bots contribute much less complex changes and should therefore be much quicker to review, and furthermore that over 60% of all bot pull requests end up not being merged at all, we see potential for change in the numbers. If bots make important contributions, they should receive as much attention as other contributors. Whether this means that developers have to change their behavior in dealing with bots, or bots need to be designed differently, remains a question that the bot community can explore. How exactly bots have to change to be more effective is something that we as a community still have to find out. But there's one thing we can already conclude. If, for example, someone does an evaluation study and benchmarks a bot against the interaction with pull requests from humans, keep in mind that an excellent bot might already be one that is accepted just as well as an average human contributor. There seems to be some bias in the interaction with bot pull requests, and we need to find out why this is the case. Only in this way we can design bots to support developers more effectively in software engineering in the future. I really hope that you enjoyed this short video. If you did, check out my YouTube channel /science. It's about software engineering research, and it doesn't matter if you're a scientist or a software engineer. I try to explain the science behind software engineering there in a way that is enjoyable for everybody and so that everybody can learn something. Thanks for your support, and if you have any questions, of course, feel free to ask them.
Okay, very good. There are a lot of comments on the chat about the presentation. So we will open for questions. Yeah, great presentation. Does anyone have any questions? Meanwhile, while people ask questions, I have one. You observed these effects that show that, for example, number of comments and time to merge and number of merged pull requests are different between humans and bots. Did you find an explanation, or do you have an idea why they are different?
Yeah, so we had some ideas. So the biggest limitation of our study is certainly that we can only describe the differences, but not explain them. But our idea is that there are, I think, three things. So first, I think there is a bias against bots somehow. And if it's only that you don't feel bad for making a bot wait, this could already be enough. We know from other studies that not only the content of the pull request is relevant for how fast it gets reviewed and accepted, but also the characteristics of the contributor. So whether man or woman or whatever, maybe also the profile picture. So one thing certainly is the bias. Another thing is we have to be realistic here. Bots today are very limited in their abilities. So we can somehow interact with them. We can ask them to do something with a very specific command, for example. But if a bot, for example, proposes a code change, a bigger refactoring, for example, it's not possible to ask, hey, why did you do this in this specific way? Explain what you did there, things like that. So they are really limited in what they can do. They are also limited in their, I would say, in their effort of pushing maintainers to take them serious somehow. So this is, of course, a challenge because you don't want to annoy people. But when you look at what human contributors usually do if they have a problem and they submit a pull request or something, and then for 3 days nobody responds to them, they ask, hey, how is it going? I just submitted this pull request. Is there anything I can do to help you? And bots usually don't do this. So after a week or so, a dependent bot would just close their pull request then and move on. So the limited abilities is another thing. And I think this is something that we really can change. So on the one hand, the researchers can find out how to design bots to be more effective. And on the other hand, we have developers who are really interested in improving their own bots and who want to apply these mechanisms. So as a community, that's something where we really can work on. And the third thing is certainly that there are differences in the content of the pull requests. So as I said in the video, the humans also contribute new features and stuff like this, bigger changes. And yeah, it would be interesting to see if there are also these huge differences in the numbers when we compare the same changes. So if humans also contribute dependency updates, if those updates get accepted more often and faster, that would be something that we would like to see in the future. So this was not part of this research project yet, to also explain the differences.
Yeah, perfect. Thank you. Alexander?
So congratulations on some amazing video and the great work. I really enjoyed it. So I was kind of wondering whether the difference in times could be attributed to people not trusting bots and essentially taking more time to check what the bot actually wants, or simply people not caring for bots and putting their contributions in some kind of, low priority pile.
So yes, we also thought about this, and what we have to keep in mind here is that really most of those pull requests that we looked at are from bots that those developers explicitly deployed to their repository. So at some point they thought, yes, this is a useful bot, we want to have it. And yeah, why they then don't review these pull requests or just accept a small portion of them is not completely clear to us. So it might be just the content that they don't find it that useful compared to other pull requests. So there are also repositories with a lot of open pull requests that they somehow have to prioritize. And maybe there also, again, the bias comes into play that when you have a lot of pull requests and you are usually happy as a open source project maintainer, you're happy if there are new contributors, if there are any contributors at all, and you don't want to make them wait. So the bot, it will be there tomorrow, okay? So you can make the bot wait, but the human contributors maybe are pissed off then at some point. So maybe that could explain some of these numbers.
Sorry, I was muted. Philip, you want to ask your question?
Did you say Philip?
Yes.
Everybody. Yeah, I guess my question is if you have tried to or considered to stratify the data a bit more and, you know, divide the bots into different groups, because I'm not sure I totally buy into the hypothesis that people are not reacting to the bot contributions because of some implicit bias. My working hypothesis would be that some of the things that a lot of these bots do are simply not particularly urgent. Because kind of, you know, oftentimes people give tasks to bots that are not kind of the highest priority things, like dependency management, for instance, which I would speculate is probably not kind of the most exciting and most urgent thing for many projects. So I wonder whether you try to see if there are types of bots for which this effect is less pronounced or maybe not even there.
Unfortunately not yet, but that's exactly what we mentioned in the last few sentences of our paper. We also looked at those recently proposed taxonomies for bots, for example, by Linda and others, who describe different facets of bots. And it would really be interesting to see if there are, apart from the content also, if there are any things that different bots do differently good. But we have not yet done anything on this on our four-page paper. But we did the first step. We just wanted to see if there's something interesting, and really all those numbers speak for the fact that we somehow have to change something. And if the implication is only if your assumption is true, your working hypothesis, then the implication would be to work more on bots that actually contribute changes that are really deemed important by developers. So at the moment, it's easy to fix dependency updates, right? So a bot can change one line and that's it, increase the number. But in the future, we really have to work on bots that contribute more complex changes. And it's a challenge, but maybe that's the implication. If you want developers to accept most of the bot pull requests, then we need to contribute changes with the bots that are actually useful to them and considered useful. But it could also be, I mean, you have to be careful here with thinking that humans always act in a rational way. So we noticed from refactorings, for example, there are some changes that would be really useful to apply today to have a long-term effect. But in the short term, people often don't see these benefits of refactoring a little thing now, and so technical debt sums up and so on. And we saw this in a previous study, that the one that I also mentioned in the video, that people think, yeah, refactorings are useful, but right now we have more important things to do. And so maybe the implication is also that if we have evidence for the changes to be useful to developers. So if we know from science that refactorings, the type of refactorings that our bots do, for example, they are really useful and they save them a lot of costs, then maybe we have to design our bots in a way that they force developers more to actually look after those pull requests and accept them more quickly and more often. It's really an open question, but yeah, we have a lot of ideas here. Yeah.
Okay, thank you. Ahmed?
Sorry to jump in here last minute. I have maybe a comment more than a question. I know that Alexander kind of did one of the first studies on bias in bots, at least one of the first studies that I know of. And I think that since then, bots have changed a lot, and the way that we perceive bots has changed a lot. And I think it would be very interesting to actually study that. And I don't know, maybe we can take that into discussion, but I just wanted to get even Alexander's thoughts on this, on the fact whether a replication or a repeat of that study is needed in the context today. The other just quick comment that I have is about something that Marvin had just mentioned. And I do agree. I think, you know, we're kind of stuck between a rock and a hard place with bots and their contributions. So I wonder if we as a community maybe want to introduce something like a bot importance index or a bot relevance index, a way to measure how, you know, the importance or the relevance of these contributions from bots.
Okay.
Again, not really a question. Maybe this is points for discussion, Marco.
Perfect. Yeah, so let's move to the third presentation. We can go back to this point in the open discussion.
Hello, my name is Chris Brown, and I'll be discussing my BotSE 2021 paper, Nudging Students Toward Better Software Engineering Behaviors. This work was done as part of my PhD at NC State, and in the fall, I'll be starting as an assistant professor at Virginia Tech. The primary motivation behind this work are these two major problems in computer science education. The first is that enrollment in undergraduate programming courses is growing rapidly. And to mitigate this problem, researchers and developers have introduced a wide variety of bots and tools and automated systems to automate instructional tasks. For example, WebCat is a tool that can automatically grade student assignments and provide feedback to students on their code. However, there's another problem, and that's even though the enrollment in computer science courses is growing rapidly, the dropout rate or the rate of attrition is also increasing. However, there's a gap in the research where there's a lack of automated tools and bots to help sustain students as computer science majors. And one of the main reasons for this high rate of attrition is bad programming behaviors. So research shows that ineffective behaviors lead to poor performance on programming assignments and overall computer science courses. Boboff and colleagues show that poor programming behaviors actually lead to higher attrition in computer science majors at universities, and overall, ultimately, these bad behaviors translate into industry. So students who adopt bad programming behaviors in their courses adopt these same bad behaviors as they become professional software engineers. This also relates to a similar problem in software engineering. So bots have been shown to be useful for automating a wide variety of software engineering tasks, for example, automating tasks for developing, testing, and deploying code. However, when it comes to bots and automated systems for encouraging developers to adopt better behaviors and supporting them as they make decisions, there are a lack of bots in this area, and the bots that they do have actually cause more frustration and are ineffective for developers. So the goal of this work is to determine if bots can be used to improve the behavior of programmers while they develop and maintain software. Specifically in this context, I'm looking at improving the behavior of students on computer science programming projects. So previously at BotSE, I introduced developer recommendation choice architectures. And this is a framework which incorporates nudge theory, which is a concept from behavioral science for improving the behavior of humans without providing incentives or banning alternative options. This framework was proposed as a way to improve the design of bots in order to help developers adopt better practices in their work. Just a reminder for the principles of this framework, there were three principles: actionability, feedback, and locality. And previously I showed that professional software engineers significantly preferred tool recommendations from actionable bots as opposed to passive or static recommendations from systems. So the contribution of this work is to introduce a new system, which I refer to as ClassBot, which incorporates developer recommendation choice architectures to encourage programmers to adopt better behaviors in their work. First, what is the target behavior that we're adopting or encouraging developers to adopt? In this case, I'm looking at encouraging programmers to follow the software engineering process, which is the set of activities necessary to develop and maintain software applications. For the purpose of this study and in the course that we studied, the software engineering process was divided into 5 phases: requirements, design, implementation, testing, and deployment. So in order to develop and maintain software successfully, developers would have to incorporate all 5 of these concepts into their development processes. This is an important problem to study because, as we see in computer science education, Boboff shows that unsuccessful students often want to skip analysis and design and begin typing code immediately. Additionally, other bad behaviors such as procrastinating and not actually reading the requirements for a program lead to poor performance by students. Additionally, this is a problem that is very rampant in industry as well, where not following development processes is one of the primary reasons that projects are over budget and also behind schedule in industry. So here's a screenshot of the ClassBot system at work. And again, this is a system that uses automated GitHub issues to encourage students to follow software engineering processes. It has all of the process phases as the icons that were printed on the previous slide, along with the specific rubric items that are related to each software engineering process phase. And again, this is a system that incorporates all of the developer recommendation choice architectures. For actionability, the system automatically analyzes student repositories to determine when they complete specific items required for the project. For feedback, it provides very clear feedback on when students complete a part of the project. For example, when the student hasn't completed a project requirement, it has a red X, but once the system notes that it's completed, the X turns into a green check mark to indicate that the students have passed this specific rubric item. For spatial locality, these recommendations are made on the repository that the students are working on as part of the issue tracker. And then for temporal locality, these automated updates were made daily on student repositories to get recent updates and changes that they made to their projects. This was compared to a baseline approach of having students go to a project website, which also listed the development process requirements for students required for each project. All right, so for this study, we had the ClassBot introduced on an introductory Java programming course, and there were 35 students total in the course, and we analyzed a total of 151 repositories. So we ignored the first two projects, which were the beginning projects, and then we used projects 3 through 5 to analyze students going to the course website and the project website. And then finally, project 6 and a final comprehensive exercise is when we introduced ClassBot on student repositories. There were two main metrics we were looking at to determine the effectiveness of ClassBot. The first is quality, and to evaluate quality, we looked at the overall project grade, which was calculated using industry standards such as static analysis tool notifications, testing, and other requirements to indicate the quality of the project, and also the number of points deducted for not following certain processes or having specific items for the project requirements. The second main thing we looked at was the productivity of students as they wrote code for their projects. And for this, we looked at 3 different metrics. First, looking at overall commits, then we looked at code churn, or the number of changes for each commit, and then also looking at the timing of commits. And for commit timing, we looked at the timing of the first commit. So this would be the timing of when the project was first announced in class to the student's first commit on their repository. Additionally, we also looked at the last commit, which would be the timing of the last commit on a student's repository until the deadline of the project. And this was also done to look at when students started and finished their project in order to measure productivity. For our results, we found that for quality, students who had ClassBot on their project received significantly higher grades, about 2 points higher on projects with ClassBot compared to those without ClassBot. So here we see that it does have a slight improvement, a significant improvement on the project and the quality of code that students submit for their work. Additionally, for productivity, we saw that code submitted with ClassBot had significantly higher code churn, so more lines of code added, removed, or modified during commits. And we also saw that it significantly improved the first commit, so the timing of the first commit, by about a week. So students, when ClassBot was present on their repository, started projects about a week earlier compared to those projects without. So to wrap up, we see here that automated recommendations from ClassBot were useful for encouraging students to follow software engineering processes. And again, overall, we saw this improves code quality and the productivity of students, specifically by increasing the grades that students received on their projects, also increasing the amount of coding activity, so a higher number of lines changed or added or modified or removed while students were writing code and making contributions to their project. And we saw that it prevented procrastination by encouraging students to start about a week earlier compared to projects without ClassBot. Ultimately, we conclude here that using developer recommendation choice architectures is an effective way to improve the behavior of programmers. Again, looking at students, we saw that it improved their behavior and encouraged them to adopt higher qualities of code, to present higher qualities of code, and also to be more productive as they wrote code. And for the future work, we aim to determine if this framework, developer recommendation course architectures, can improve the behavior of students as well as software engineers. So can we use this framework to recommend other types of behaviors, and can we also develop new types of bots to improve the behavior of professional developers in industry? Thanks for your time, and I'm looking forward to discussing this more at the workshop.
Okay, very good. Let's open for a question. I think Ahmed has a question.
Chris, as usual, a very nice talk and intriguing bot. I have a question about the students' perspective. So did you speak to the students at all to see how they perceive the bot?
We did. There was some feedback on the bot. Not too many students filled out our sort of wrap-up survey at the end. But overall, it was pretty helpful. So they thought it was helpful in terms of reminding them of things to accomplish, like for their project, and it was easier for them to sort of check how much they'd done and check their progress. So overall, it was helpful. I think the main issue was they wanted more instant feedback. So the bot itself kind of like updates every day. But if you're a student and you're making like multiple commits a day, especially like towards the deadline, you want to see what each change actually does. So that was the main sort of complaint students had.
Okay, thank you. Tom?
Yeah, it was not really a question. I don't know to which extent, how generic is this bot? Suppose that like I would want to use this bot in my own lecture, software engineering or software evolution or whatever. How configurable would the bot be if someone else wanted to use it, and if it's not exactly the same process to be followed or the same deliverables? So how easy is it to use the bot by someone else and to configure the bot for more specific or different needs?
Mm-hmm. So I think it is configurable in terms of the overall process. However, the specific rubric requirements would have to be based on each individual course or each individual project. So for example, just changing it from the last two projects that we analyzed ClassBot on was a bit of work in terms of like fitting it to the specific requirements for that project. But I think if you want to make it more general, it would also be easy to configure and apply to any other classes. But that's something that's also part of the future work, where we aim to sort of expand this to make it easier to adopt for classes, and also look into some sort of industry version where it's actually encouraging professional software developers on open source projects to also follow these same sort of processes.
Thanks.
Okay. Any more questions for Chris? Otherwise, we can move to the open discussion. So you can call questions for any of the presentations or anything specific. I know that Ahmed has already raised a point for Alexander paper. That's not from Alexander. But maybe if Alexander knows this work, can you comment a little bit about it? And your opinion about it?
Thank you. Thank you very much. So I can summarize this paper very briefly, and then of course I'm curious to hear what Ahmad and Marvin think about what was going on essentially. So in this paper, the researchers have performed a run of the very same bot twice on Stack Overflow. Once this bot was pretending to be a human, so it had more or less like human avatar and human-like name. And the second time, it has explicitly stated that it was a bot, and it had a bot-like avatar, and it had a bot-like name. So the bot was killed after a couple of days. The human participant, or such as the human pretending bot, successfully survived the experimentation time, which was, if I remember correctly, a month. So the conclusion they derived was that the expectations that Stack Overflow participants had from bots were significantly higher than those from humans. So they were more likely to forgive the mistakes made by something which looks like a human than by something which looks like a bot. And the tricky part here is that in whatever machine learning based studies we are performing, what we are typically doing, we are creating manually some kind of golden set, and then we are trying to create an automation which approximates it. But if you know that the expectations from the automation are higher than expectations from human beings, then this entire machine learning-like approach is simply wrong, because we can never be better than human beings. So that's a brief summary.
Perfect. Marvin, do you have any thoughts on that?
Yeah, I know this paper, and similar to our work, it was more or less a mining study. So we look for it on existing data sets and do some correlational research. And I think it's very important to stress that, at least my point of view is that these kind of research projects are starting points. We can't jump to strong conclusions from this point. So maybe also what I did in telling, yeah, there is a bias, was a bit quick, but what we have to do now is to go deeper and do some qualitative studies and find out why there is this bias. And we can come up with a lot of explanations. For example, for the Stack Overflow study, Stack Overflow is not only about I want to help you, that's my purpose. It's also about playing this reputation game, for example. So people there compete in being the fastest and being the one who gets the most upvotes for their answer. And if there is a bot competing with them, maybe they simply get pissed off in this situation. And the community could be a complete different one on GitHub, where they might be happy if anybody submits something useful. So, so my point here is that these studies, the Stack Overflow one, but also ours, provide some very nice starting points to motivate more work that goes now into the depth and checks out why there is this difference.
Any more comments? You can just raise your hand if you want to ask a question, or just post on the chat. Meanwhile, I have a follow-up question on that, because we were talking about deceiving humans, about being a bot or not, and about detection of bots. In the first presentation, it was just using the names. How did you identify bots, Marvin? And how do you suggest that people that want to avoid being deceived can do in real world?
Okay, so the first question is simpler to answer. So we combine several approaches. So first we look for the names. There are several ways to identify bots by their names. The easiest one, and the one with no false positives, is the one where you just look at those identified as bot by the bot tag, which is in square brackets. And so this is one possibility. Then there are some patterns that you can use to detect bots with a high probability of low false positive rates. So we identified a huge amount of bots by the name. Then we requested a list of the most active GitHub users and inspected them manually. So those users who really contribute a lot of pull requests and which is always a bit suspicious if you contribute like 10 pull requests per day. And we took them and also went through this whole list and identified the bots by their profile. And the third thing was we were not the first researchers who attempted to detect bots. So we also took a data set of known bot names from a previous study that I think it was also a BotSE paper last year or the year before. So they already provided us with a list of bot names, and we combined all of these approaches and had some really nice confidence that we have not too many false positives. And we also share this, maybe that's interesting for you, we share this list of bot login names that we found on our GitHub repository in supplementary materials. Okay, could you repeat the second question? I think this was more tricky.
Yeah, how do you suggest for the communities if they want to avoid being deceived? How can they identify the bots? Maybe using some of those techniques? Do you have like something ready for them to use?
Do you assume that currently a lot of people try to hide the identity of bots? Is this?
I don't know. That happens a lot on Twitter, for example, but I don't know in GitHub if people are interested in deceiving that they are bots or not. That's an interesting question per se.
Yes. I think the challenge, if you want to do it, that's an ethical question, and I can't answer this, but we have to decide as a community what is acceptable here and what is not. And also talk to the people, and not only talk within our research circle, but also talk with those who we fool here. But if you, I think that the main challenge is that as soon as someone comments on a pull request by a bot that you try to prevent being a human, is that your bot won't have the ability to respond in a meaningful way. So we are not at a point from a technical perspective where bots are great at hiding their identity. They don't understand what people ask them in their pull requests, and at this point they will already notice, okay, this is not a human.
Okay.
So yeah, I think it's just hard from a technical perspective to pretend this. Yeah.
We maybe have time for a last question or comment. Diego?
Yes, thanks, Marvin, for the very nice talk. I just have a sort of a comment on so I saw your data set has a lot of DependerBot PRs, right? And this was very interesting for me because we did a study on DependerBot PRs on the security context. We published recently at MSR, and there we saw a very different picture. The developers were very receptive. They would merge the vast majority of PRs, and they would reply often within a day. So very fast responses. So this is really just to showcase that I think how developers respond to bots would definitely depend on the context. So the DependerBot comes and tells you there's a vulnerability in your dependencies, you're more likely to reply very fast and try to solve it as soon as you can. And I think that sort of goes into the direction that Emad was saying, that there are bots, there are developers I think perceived as being that their task is more urgent to respond. And while some other bots, they say, okay, that's an interesting, there's a sort of an awareness. They came to us, they have a patch or some contribution. We will get to that bot in a due time. So I think certainly this differs a lot. And in the future, we might actually have more like a definition of the classes of bots that developers reply more quickly, I should say, and bots that they can wait a little bit longer. Yeah.
Definitely. I think we are at the very beginning of understanding what is happening there, and maybe DependerBot. I don't have the data for the specific bot in our data set, but maybe it was one of the few that performed actually well. I don't know. From your study, you have some good numbers there. Maybe the other bots were bad. Yeah, definitely something we have to look into now.
Yeah, it definitely helps. The DependerBot is backed by GitHub, so developers sort of have a higher trust that what is coming is sort of being tested. Microsoft and sort of has all of the technical prowess behind it, right? As maybe some less known bots come and they maybe don't trust them as much. Yeah.
Okay, excellent. It was really nice discussions with a lot of ideas. I think we are going to move to the break. We are going to have a short break so you can drink a water, a coffee, or just refresh so you can start the new sessions in about 7 minutes.
Hello, everybody. Welcome back from the break. I hope all or most of you made it. I'm Stefan Wagner from the University of Stuttgart in Germany, and I'm going to chair the second session. We will have 4 great presentations here. Starting off with a journal first presentation where we actually get an interesting talk on a paper that was just published in the Journal of Software and Systems, followed up by 3 regular papers that were submitted to the workshop. And I think we should start directly and don't waste time and have a look at the first video.
Hello everyone, my name is Mehdi Golzadeh. I'm a PhD student at the Software Engineering Lab at the University of Mons in Belgium, under supervision of Professor Tom Mens and Dr. Alexandre Descamps. I will present the result of our journal first article entitled A Ground Truth Dataset and Classification Model for Detecting Bots in GitHub Issues and Pull Request Comments that we published in Elsevier Journal of Software and Systems in May 2021. Open source software development is a collaborative task, and open source developers work remotely and in geographically distributed teams to achieve their goals. Some open source developers are actively participating in several different projects. They use available software bots or create new ones to reduce their daily workload by delegating routine and repetitive tasks to these bots, which are known as DevBots. DevBots have become an essential part of software development. They are increasingly active in social coding platforms such as GitHub and GitLab. They are used to create pull requests, submit issue requests, commit code, interact with external tools, and communicate with project contributors through comments. We noticed the prevalence of bots in GitHub activities for the first time while we were carrying out an exploratory empirical analysis on the effect of GitHub comments on the acceptance of pull requests. The analysis revealed that the proportion of pull requests involving bot comments was almost twice as high as pull requests without bot comments. This shows that bots seems to play an important role in socio-technical development activities. As such, it's important to have automated methods to identify such bots and distinguish them from real human contributors. We presented our first results in this direction during the BotSE 2020 workshop, and the research published in GSS 2021, on which I report today, can be seen as a significant extension of that work, including a dataset, a classification model, and an open source command line tool for identifying bots in GitHub comments. Identifying bots in GitHub repository comments is not a simple task, since bots use natural language phrases to communicate about their tasks with human contributors. Therefore, we devised a machine learning model to classify whether active accounts in GitHub repositories should be considered a bot or a human, based on some features that can be derived from their comments. As a preliminary step, this required us to create a ground truth dataset that would allow us to train and validate such a classification model. Such a dataset is a first contribution in itself, since we are not aware of any other publicly available dataset that classifies GitHub accounts as humans or bots on the basis of their commenting activity. To create this ground truth dataset, we used the GitHub API to download comments from a large number of GitHub repositories. This resulted in over 10 million comments of more than 873,000 distinct accounts from over 136,000 repositories. We developed a rating application to allow us to manually classify over 5,000 GitHub accounts on the basis of their issue and pull request comments. To achieve high inter-rater agreement, we use the following process. The comments of each account were inspected by at least 2 raters. Difficult cases were inspected by a 3rd rater. Cases with disagreement were discussed by all 4 raters to reach a consensus. This process leads to a manually validated ground truth dataset containing 4,473 distinct human accounts and 527 distinct bot accounts. To create a classification model for distinguishing bots from human accounts on the basis of pull requests and issue comments, we relied on the following features. During the rating process, we noticed that bots tend to produce groups of similar comments and tend to use a specific text pattern in their comments. There, the first feature we used was the number of distinct comment patterns. This required us to compute comment similarity. To do so, we combined the well-known Jaccard and Levenstein distance metrics and used them to create cluster of comments based on the DBSCAN data clustering algorithm. In this figure, we observe that most humans are along the diagonal line, which indicates that the number of patterns is close to the number of comments, and almost all bots are along the horizontal axis. This means that the number of comment patterns for bots remain stable and low regardless of number of comments. As a second related feature, we used the number of comments. Indeed, an account containing 8 comment patterns out of a total of 10 comments is more likely to be a human compared to an account containing 8 comment patterns out of a total of 100 comments, which is more likely to be a bot. As a third feature, we used the number of empty comments for each account. This feature was motivated by the fact that bots tend to produce informative comments, whereas humans often leave pull requests and issue descriptions empty. A fourth distinguishing feature was the distribution inequality of comments in comment patterns. We observed that comments are less evenly distributed in bot comment patterns than in human comment patterns. We used the Gini coefficient to compute this inequality. The figure shows the difference in the distribution of Gini coefficient for bots and human commenters. Based on these 4 features, we created 5 types of classification models, namely random forest, k-nearest neighbors, support vector classifier, simple decision tree, and logistic regression. We used a 10-fold grid search cross-validation to compare the performance of these classifiers with varying parameters on our ground truth dataset. 60% of the dataset was used for model training and validation, while the remaining 40% were used to evaluate the performance of the selected model. We achieved a very high F1 score of 0.98. For more details, we refer to paper itself as well as to the replication package that we made available on GitHub. In order to use the bot identification model in practice, we developed an open source command line tool in Python. It's called Bodega and can be installed directly from its GitHub repository. Here is an example of how the tool works in practice. In its simplest form, an address to the GitHub repository you wish to analyze and a personal GitHub API key is required. The tool will download all pull requests and issue comments from the specified repository for the specified period of time, which the default value is last 6 months. Then it computes all features required for the classification model, applies the model on the computed features, and reports the classification result. For further details on the tool, we invite you to visit its GitHub repository. Like any research, the presented work has some known limitations that should be addressed in future work. First, our classification model is not able to identify human accounts that mix their normal human behavior with some automated tool that acts on behalf of the user to carry out some repetitive tasks. We baptized such accounts as mixed account. In our BotSE 21 publication, we propose a new classification model that helps to overcome this problem. The second known limitation is that the classification model only analyzes PR and issue comments. Bots can also be active in Git commits or other activities. The approach we followed for creating the classification model also seems to work well for Git commit messages. We developed and presented a prototype tool called BotSE during the Benevolent 2020 workshop. The tool can be found on this address. Thanks for your time, and I would be happy to answer any question.
So, great video. Thanks for that. You received a lot of praise in the chat. I guess you've seen that. And there are some questions on the video, but maybe we move that to the end if we have time. And I think I've seen a question by Preetha. Do you want to read your question?
Hello. Hi. Yeah. Can you hear me?
Yep.
Yeah.
Go ahead.
So great presentation, and I especially appreciate the data set that you created. So I was wondering that how much effort did you spend in analyzing and annotating the data sets? Because I feel like, so much effort needs to be spent in manually annotating all these data sets that we need to train these bots. So I was wondering if you have any insights or along the line of like, is there a way to automatically curate such data sets, and can we use some other kind of resources such as developer chats, for example, to automatically train these bots?
Actually, for this data set, I think we had at least 1 month working on it, not full time, but we computed the time that we spend on rating these accounts, and we reported on our paper. But the tool helped us a lot to work remotely, and it was very helpful to rate each one of the rater work at home, and it was taken. I think we worked on rating around. I remember it was around 20 hours or so, exactly on the application. But about the tool, I didn't understand the second part of your question about the tool to train the.
So I was wondering if there is any way, like, if we could like use the data that we already have and use some kind of transfer learning or something to automatically curate, or like, and use these data sets instead of going through all the effort of manually annotating the data sets. So I don't know if you have like thought about this, or if you have any insights on that.
Actually, we didn't find any similar data set or similar knowledge. We found some research about identifying bots in social media, like bots in Twitter or bots in Wikipedia, but the way they work is completely different than what we have in social coding platforms like GitHub. So we tried to have a new data set by ourselves, but I believe we can use the similar techniques on other studies that we have used. I mean, I was wondering why people are inventing the wheel again. in our researches that's presented today. They can use our method to identify bots, but in our 3 or 4 research that's presented till now, I found that people are using their own method to identify bots. But so it depends on the research and researchers.
Thank you.
You're welcome.
Great, thanks. We can take one more question if you have one.
Yeah, actually, I have one.
Sure,
If no
ahead.
one has, yeah. So first of all, thank you for the nice presentation. And actually, this is a nice study, and it will help a lot of the researchers to separate the bots from humans. So actually, I have a quick question. So based according to my understanding, that the proposed approach heavily depends on the comments, right, on pull requests and issues. So did you investigate the minimum number of comments that the bot should have, or any account should have, to give an accurate classification? For example, do I have, for example, 5 comments at least for your approach to give a good classification or accurate classification?
Yes, we had analysis in our paper that shows that starting from 5 or not 5, starting from 10, the accuracy will go up to 90%, more than 90%. And starting from 5 comments, it's around 85% of accuracy with our model.
Okay, cool. Thank you.
You're welcome.
Good. I think it's time to move on to the next talk. If you have more questions, maybe we can talk about that in the open discussion section, and we go to the Chatbot.
Thanks.
Hi everyone, my name is Drago Sherban and I am currently a master's student at the Eindhoven University of Technology in the Netherlands. Today I will present the paper Chatbot, proposing fixes for static analysis warnings with GitHub suggestions. This paper is co-authored by Bart Goldstein and Ralph Holdorp from Philips Research and Alexander Serebrennik from Eindhoven University of Technology. In their work, developers sometimes use static analysis tools. Static analysis tools are a class of tools that analyze the source code of a program in order to identify various problems, which are then displayed as warnings. Although static analysis tools are widely known for their benefits, they are underused. One of the most commonly reported limitations is the lack of automated fixes, since developers are almost always required to fix warnings manually. This often proves to be overwhelming, especially when too many alarms are displayed at once. Finally, static analysis tools provide too many false positives. Hence, given these 3 limitations, developers often need to decide which warnings to prioritize. But how do developers decide which warnings to prioritize? Well, there are 2 main factors. First of all, there is the estimated fixing time, and then there is the proximity to a deadline. When developers are close to a deadline, they tend to focus more on the high severity issues and ignore the low severity ones. However, this is a problem. If developers avoid fixing some warnings, this could possibly lead to problems in the program. Although many tools and bots have already been proposed in literature to address this issue, we believe that we can go one step ahead. Meet Chatbot, a GitHub app that can be installed on any Java repository and proposes fixed suggestions for SonarQube violations. What makes Chatbot unique in comparison to similar bots is the way of proposing fixes, which we call the GitHub suggestions mode. In this mode, the bot proposes fixes only for the changes introduced in new pull requests. The generated fixes are integrated in the code review using the GitHub suggested changes feature, as you can see in the image on the right. This way, developers have the freedom to decide whether individual fixes are accepted or rejected. This brings us to the main goal of our study, which is to understand the relative strengths and weaknesses of the GitHub suggestions mode. To understand these relative strengths and weaknesses, we have introduced 2 other operation modes, which were inspired from literature, the pull request mode and the legacy mode. In the pull request mode, the bot proposes fixes only for the changes introduced by developers in pull requests. The generated fixes are proposed via pull requests to the branch created by the developer with 1 commit per fix. In the legacy mode, the bot is invoked based on a predefined schedule. Fixes are suggested for all fixable warnings identified at analysis time. These suggestions are proposed via a pull request to the analyzed branch. Now let's have a quick look at the evaluation design. First of all, we have conducted the Wizard of Oz experiment. Then we have augmented the Wizard of Oz experiment with semi-structured interviews in order to obtain a better understanding of the user experience. Finally, we have asked the participants to fill in a questionnaire which was based on the modified technology acceptance model. The evaluation has been conducted with 5 professional developers from Philips. The Wizard of Oz experiment is a method widely used to evaluate systems that are not fully implemented, while preserving the authentic behavior of the participants towards the system. In this experiment, the participants are required to interact with the system, which they believe it is autonomous, when in fact it is operated behind the scenes by an unseen human, which is called the wizard. Then, the interaction of the participant with the system is captured and insights are inferred. The first step in the design of the Wizard of Oz experiment was the preparation of a high-fidelity environment, which consisted of a GitHub repository with a Java project and a SonarQube instance attached to it, as well as an instance of Sobot. Then, in the actual experiment, the participants were instructed to perform some tasks that resemble some of their daily work activities, in particular implementing some functionality and reviewing some code. Since the bot was not fully implemented at the time of the experiment, some bot operations were conducted manually by the wizard, especially in the evaluation of the legacy mode and the GitHub suggestions mode. When manual operations have been performed, we have also introduced one intentional wrong fix in order to evaluate the reaction of the developers. The Modified Technology Acceptance Model questionnaire consists of 12 statements on a 7-point scale, ranging from extreme disagreement to extreme agreement. It is used to measure perceived usability based on 2 variables, namely perceived usefulness and the perceived ease of use. We opted for this questionnaire because it is used to evaluate the current user experience rather than the expected experience. In the evaluation of the legacy and pull request modes, only 1 out of 5 developers identified the wrong fix. This could mean that pull request based fix suggestions might not encourage developers to review the suggestions carefully. In addition, other developers reported that a drawback of these modes is the fact that there is no information provided regarding why a fix is suggested. Some participants reported that in these operation modes, they spent more time understanding why a certain fix is suggested, rather than on the soundness of the fix. Finally, participants mentioned that when too many fixes are proposed in a pull request, this could be overwhelming. The GitHub suggestions mode, however, was preferred by 4 out of 5 developers. Participants mentioned that this mode is easy to integrate in their daily workflow, especially due to the code review style suggestions. In addition, developers found it easier to identify wrong fixes in this operation mode. Reported benefits included the prevention of new issues from entering the codebase and the fact that the fix suggestions could represent learning opportunities for new developers. However, one participant found the mode unintuitive, mentioning that suggestions placed next to manually written code might actually be confusing for some developers. The results of the Modified Technology Acceptance Model questionnaire showed that the overall usability score is 79 out of 100, which means that the bot is considered acceptable from a usability perspective. Now let's sum everything up. When developers use static analysis tools, they often have to prioritize which warnings to address. Sometimes, some warnings tend to be ignored, potentially causing issues in the program. Although some solutions have already been proposed to address this problem, we believe that the right way of doing it is by integrating the fix suggestions in the code review itself. To test our hypothesis, we built a GitHub bot that proposes fixes for SonarQube warnings using GitHub suggestions. To evaluate this way of proposing fixes, we introduced 2 new operation modes, which were inspired from academic literature. Then, we have conducted an evaluation study consisting of a Wizard of Oz experiment, which was augmented with a semi-structured interview, as well as a questionnaire that was based on the Modified Technology Acceptance Model. The results are showing that GitHub suggestions are actually a viable mechanism for proposing fixes. Thank you very much for listening.
Okay, thanks for that great talk or video. Already see one question by Tom. Do you want that? Do you ask that?
Sorry, I think it's quite simple question. So in the beginning of the presentation, you said that it was on Java project. So I was wondering how specific is it for Java? Since it's about SonarQube, so it's also these types of static analysis tools or analysis tools in general are also applicable for other programming languages. So does your bot also apply for other programming languages, or would it be feasible to propose a similar bot that also works for other programming languages?
Yes, indeed. I think it would be easy to extend the SOBot because the fixing module, which for now is created only for Java, is basically a separate component which can be linked to the main bot itself.
Mm-hmm. Okay. Thanks.
Any more questions? I definitely have one. As you might know, Marvin and me and some others did a study on the refactoring bot, and we quite decidedly wanted this to be as part of a project. We chose a student project, which has, of course, its own problems, but did not do an experiment because we thought the environment might be too artificial. So how do you evaluate that? Do you think it's the setting in a controlled experiment was good enough to really evaluate how people interact with the bot, or did you see any problems there?
Well, it was a controlled experiment, so I don't really think that it reflects reality that well. I mean, I think that if time is not an issue, I would assume that rather a longitudinal study in an industrial setting would actually be a better reflection of reality.
Okay, do you think that influenced your results in any way, or?
Yeah, definitely, because after all, our study involved just having the developers solve some very simple tasks, which might or might not have been related to what their daily work is. So I believe that it's better if we could see in a real scenario how the bot is actually accepted, how it is actually used.
Thanks. I also see Neil has raised his hand. Go ahead.
Yeah, thanks. A very interesting study. I guess I have a similar question to Stefan, which is, it seems like the Wizard of Oz thing allows you to get the study rolled out pretty quickly, right? You don't have to focus on actually implementing the bot and so on. What I think is more interesting is when you talk to these professional developers, is this within the workflow that they would expect, as opposed to say running SonarQube on their project as it's normally configured to do? Do you have some way of dealing with that mismatch?
Before we set up the experiment, I actually asked a few developers about, within Philips, what their daily workflow typically is like. So when I created the experiment, I just tried to make it as similar as possible.
So they would have SonarQube running somewhere on their Philips code base and deal with static analysis warnings, but not in this sort of GitHub actions approach.
Yes.
Okay, thanks. I had one other question, which is, do you have can we see the tool, or I couldn't find a link in the paper?
No, not at this moment. We are still in discussions regarding the open sourcing of the tool.
Okay, thanks.
Good, thanks. We could go for one more question. We have one. maybe we'll have a bit more in the open discussion. Then I think we can move on to the next video where we go back, so to say, to identifying bots again from Mehdi.
Hello everyone, my name is Mehdi Golzadeh. I'm a PhD student at the Software Engineering Lab at the University of Mons in Belgium, under supervision of Professor Tom Mens and Dr. Alexandre Descamps. In this work, I had the chance to collaborate with Dr. Eleni Constantino from the Eindhoven University of Technology. Here I'm going to present the result of our paper entitled Identifying Bot Activity in GitHub Pull Request and Issue Comments in the 3rd International Workshop on Bots in Software Engineering. In our previous work about identifying bots in GitHub accounts while analyzing accounts to create a ground truth dataset, we noticed that some accounts have a mixed behavior of human accounts and bot accounts. With further inspection, we figured out that some developers use automated tools to carry out some of their repetitive tasks with their own account. We called such accounts as mixed accounts. Since the approach we followed in our previous work was based on similarity of comments and comment patterns and was not able to identify such accounts, we excluded these accounts from our ground truth dataset. Mixed accounts are getting more and more prevalent by the increasing number of automated tools and apps for social coding platforms. The motivation of this work is that we need a model with a finer granularity to identify which activity is done by a human and which one is done by a bot. To create a model to classify bots and humans based on the content of their message, we need a dataset of humans and bots comments. To conduct this study, we used the ground truth dataset of our previous study, which is recently published in the Journal of Software and Systems. We picked 9,641 bot comments from the ground truth dataset of our JSS paper and randomly selected the equal size of human comments to form an appropriate and balanced ground truth dataset for this study. Given that we want to classify comments based on their content, we have to process natural language text. Therefore, first we need to convert the content of comments to an appropriate representation for classification algorithms. There are a number of methods to do this pre-processing task, such as bag of words, TF-IDF, word2vec, and BERT. We tested all these pre-processing techniques and their variants, and we achieved the highest accuracy with a combination of bag of words and TF-IDF. We split this dataset into a training and a test set. Approximately half of all comments was used as a validation set in a grid search cross-validation process to determine the best input parameters, the best classifier, and to train the selected model. The test set was used to evaluate the performance of the selected model on the new and unseen data. While creating the training and test sets, we ensured that comments belonging to the same account were not spread in both sets. We followed a standard grid search cross-validation process to do both hyperparameter tuning and selecting the best classifier. For the classification task, we used 4 different classifiers: support vector machine, multinomial naive Bayes, random forest, k-nearest neighbors, and 0R classifier as a baseline to compare the models. This table shows the result of the training phase. In terms of overall performance, naive Bayes and SVM appear to be the most promising classifiers. The SVM, random forest, and k-nearest neighbors classifiers have high recall for human comments, but a rather low recall for bot comments. It's clear that all models outperform the 0R baseline classifier. In this table, we observe the result of the evaluation of the final selected model on the test set containing 4,852 human comments and 4,850 bot comments. The results show that around 90% of bot comments and 86% of human comments are classified correctly. The higher recall of bot comments and higher precision of human comments indicate that the model performed better in detecting bot comments. One of the positive points of this model is that the model also provides the probabilities associated with predictions. A probability close to 1 indicates that there is a high level of confidence in classifying the comment as bot comment. Conversely, a probability close to 0 indicates high confidence in classifying the comment as a human comment. A probability close to 0.5 indicates low confidence in the prediction. We observe that most comments have an associated probability close to 0 for human comments and close to 1 for bot comments, indicating high confidence in the prediction. Why this model is better? In our previous work, we claim that an account is a bot or a human, and we know that in some cases, especially in mixed accounts, we are wrong. Also, the fact that we have mixed accounts is something interesting to analyze individual comments instead of set of comments. The new model not only works on individual comments, but also is able to predict accounts with a confidence level. We tested this model to predict the type of accounts in the ground truth dataset of our previous paper based on some metrics like sum of the probabilities of comments, mean of the probabilities of comments, and we achieved an accuracy comparable to the previous results. The new model provides the associated confidence for each prediction in addition to the prediction itself. It makes it possible to make sure about the correctness of the prediction by ignoring predictions with low confidence. This can be helpful to stay on the safe side and have strong and correct predictions. We also tested this model on a small dataset provided by a research group from the Eindhoven University of Technology who are currently investigating mixed accounts. Our model was able to correctly classify about 80% of the cases. To sum up, we had problem with identifying mixed accounts, so we decided to have a more fine-grained model and predict the type of comments instead of accounts. We created a dataset of human comments and bot comments from the dataset we created in our previous study. We used a combination of bag of words and TF-IDF to pre-process comments and feed them to classifier algorithms. We used a standard grid search cross-validation process to do both hyperparameter tuning and selection of the best classifier. We achieved a promising F1 score of 0.88 on the test data. Thanks for your time and consideration, and I would be happy to answer any questions.
Great, thanks for that very nice video again. And we already have a quite lively discussion in the chat, and I think I want to bring that to here. Neil, do you want to ask your question?
Yeah, my question was about detecting bot comments in which the bot author is trying to make it look human. And like Tom mentioned, I don't know if that's actually the case other than a few research studies maybe.
Actually, we only investigated bots in GitHub as some mentioned that in GitHub, bots don't try impersonate and try to show that they are human. So, and our model is based on their comment and the repetition of their word in their comments. Like we use count vectorizer and TF-IDF to to convert their text to machine readable thing. So I believe that our model works on repetition of their comments. So their repetition of word in their comment. But I don't believe our model or tool could be, can identify chatbots or bots that are trying to use NLP to be more like human.
Yeah, I guess you wouldn't know if it was a bot or a human, right? Like when you do the ground truth, if the humans don't know the difference, then the machine learner obviously won't be able to tell either. So you had to start with something that said, I am a bot when you did the labeling, is that correct?
No, in labeling or data set, if your question is about labeling or data set, is we checked their comments, and we didn't find, as if there was some bots like what you mentioned. We couldn't identify them because we were looking only on bot comments, their comments, and we decide based on their comments. And if if it's like human comments, we cannot identify them. And this can be one of the threat to validity of our work.
Okay, thanks. I think I would like to go to Mohammed's question.
Yeah, well, I think, well, thank you for the presentations, like both they're well done and nicely done. Well, I think my question is, I think, in line with what Neil were asking. So you partially or answered the kind of the question of, but also like it seems that the bugs that are generated by bots or the comments generated by bots on GitHub will be also very similar, which is to the comments that are normally generated by humans, because developers normally, we create patterns, like developers create patterns while they're commenting, and these kind of comments normally shorter than the one that appears on normally in conversations on chatbots that in social media, for example. So is there challenges here for identifying these kind of the comments? And because these bots were there to help, right? And normally developers repeat these tasks and the comments will be very short. So
yes, I understand. And the most part of the failure of our model is about humans that are using short messages and repeated messages. If you have a look at our paper, the model only detect 3 bots as bot comments as human comments, but 176 human comments as bot comments. So there are human comments that are like bot comments, as you said. It needs further work to increase the accuracy of the model and to cope with this problem.
Okay, thanks. I think we can take one more question. There's none in the chat. Who's raising their hands? But I have one. I was wondering a bit if you envision use cases for your model. I mean, of course, it's very neat to have something like that if you do empirical research. But do you see other applications for the model to classify the comments?
One of the purposes I explained in my presentation is identifying mixed accounts instead of only human and bot accounts, but we didn't find any like practical use of identifying bots other than research purposes.
Okay, thanks.
You're welcome.
Don't see any more questions. So if something else comes up, we have our open discussion after the next video, which will be about the designing of a bot for the efficient distribution of service requests, and we can play the video.
Good evening, ladies and gentlemen. Today we are going to discuss about designing a bot for efficient distribution of service requests. Myself, Orkodip Bosu, and my colleague Kunal Banerjee from Walmart Global Tech India have developed and co-authored this article. Our organization, Walmart, is a retail organization having footprint in multiple countries, operates in both online and offline. It's also in B2B and B2C business. We are part of the IT division, which manages the backend infrastructure, develops solution for the customer, and makes the overall operation seamless. What is service request? In any organization, there are multiple teams. To achieve desired business goal, teams need to collaborate. To work with other team, a service request needs to be raised on the desired team's Scrum board. Engineer will pick up the ticket and work on it. If he or she needs further information, he will collaborate with the reporter and together will drive towards a solution. Here we will talk about Jira software as a service request management tool developed by Atlassian. What is the problem statement? Every day thousands of tickets are getting generated. Tickets are also known as service requests. For any given team there are 30 tickets per day. The role of Scrum Master used to be monitor the Jira service board. There are multiple service boards. Assign the tickets manually to the team member to follow up with reporters, with the engineers. We thought the entire service flow management can be automated in a better way. What is the life cycle of a service request? When the engineer creates it, it is in the backlog stage. Then work in progress. After completing the work, it is in the ready for review. In between, the ticket may go to the block stage, and after exchanging the necessary information, it gets unblocked. And when both reporter and the engineers agreed for the final conclusion, then it's marked as done. We have deployed our bot in the system so that every state change alert of the ticket is notified towards the engineer, reporter, the Scrum manager through different communication platforms, be it Slack or Teams. Talking about the technical stacks, we are using Jira API and Jira query language to monitor the board. The entire logic is written on Python programming language. Unix is used for fine-tuning and scheduling. Let's have a look into the production screenshots. In last one day, there has been 11,792 tickets across Walmart. If I talk about 1 hour or 60 minutes, 376 tickets has been created. Have a look into the production board. So you can see that tickets are getting assigned to a engineer. This is in the backend, it is done through a bot. For confidentiality purpose, we have masked some areas. Now let's look into the another service board. From the first name, you can see no one engineer have got the ticket simultaneously. It has been evenly distributed among the India and the US engineers. Look into the assignment process. This ticket was created on 17th March 11:53 AM. Within 15 minutes, bot observed the ticket and assigned to one engineer. Similarly on this case, it got assigned within 11 minutes. There is a notification feature by the bot which helps to maintain SLA. Have a look into the example. On 23rd February, 3:54 AM, Rohit, one reportee, submitted his use case. There was no update on this ticket. The bot came into the picture and updated. There is no update for last 8 days. By that, the engineer and the reportee both got notified. Engineer came back with necessary information. And now the Carlos, the engineer, replied his findings. After some days, Rohit again updated his point. Again there was silence. Bot again come into the picture and updated. So by that, bot is communicating between the engineer and the reportee, also the service manager, and helps them to notify that, hey, there are some backlog tickets you need to work. So by that, it is helping to maintain the SLA. As of now, the bot is in 18 boards in Walmart. When we wrote the article, it was on 11 service board. Out of them, 6 teams have provided a experimental survey result. If you look into the left side, standard deviation have been decreased. Almost equal number of distribution of the service request without any biasness towards the engineer. Looking to the right side, the average ticket resolution time have decreased significantly. Most importantly for team 2, team 6, team 5. Blue one represents the pre-bot and the gray one post-bot. We have ran a satisfaction survey among the engineers and the reportees. We understand that 100% members agreed it have streamlined the process. 96% agreed it have helped them to maintain the SLA, service line agreement. There has been few negative points we have noted in the article and will work towards mitigating those. Looking into the ideas that did not work in practice, expertise-based allocation. To help this understand, I will give you an example. Consider among 5 members team, Mr. A is good in technology X, Mr. B is good in technology Y. If tomorrow either Mr. A or B or both leaves the organization, there will be knowledge gap. To overcome that, we are distributing the ticket fairly among all the engineers so that newcomers also learn the technology. There is another problem, open ticket count based allocation. Example, if there is a logic that if you have already 5 tickets, bot will not assign you any further, then there is a 10 that engineer will keep their ticket open so that bot sees you have already a ticket in backlog and it will not assign you further. To overcome that, to remove that kind of biasness, bot assigns everyone equally. Now, what is the requisites to onboard the bot for a new team? We need the service desk details, that is the Jira board, the logic by which the bot will work, and the list of engineers, the operational hours. Just to add a note, the bot is working 24/7 by 365. It also can work in shift because in our organization engineers work in shift, so the bot also works. The bot is providing service for almost all the continents. However, most of the engineers are from India and US. Our future work. First, we need to integrate the bot with the team roster. So absence management of an engineer can be tracked by the bot, and on a time off, the engineer does not get assigned with any ticket. We are planning to integrate artificial intelligence and machine learning to analyze the pattern and overcome the negative feedbacks. A lot of PMO works has been eliminated by the bot. Still, there is scope for more. We need to deploy the bot for more teams and learn from their feedback and together enhance it. That I am stopping here. Thank you very much for your time and patience. I am open for taking any questions, feedback, suggestion. Open to you all. Thank you once again. Good evening.
Thanks for that nice presentation. We have a couple of comments in the chats, but not a real question. Anyone of the commenters care to bring that up as a
thank
comment
you.
or question?
Because I see a couple of questions, it will be really good if you just call out and so that it will be easy for me to answer.
Yeah. Khaled, do you want to start? You raise your hands? No? Do I have something from Neil? Do you want to say something, Neil?
Yeah, it just struck me looking at it how in a company where you're being paid for your work, if someone says, like the bot says, hey, do this job, you have a much different reaction to the bots that I normally see, which is an open source project, hey, please respond to my pull request. I mean, the open source maintainers less enthusiastic about that, whereas I would imagine at Walmart, if the bot tells you to do something and it's sort of an official thing, you kind of have to do it. I don't know, maybe you have some comment on how people react to that from a sort of social perspective.
Correct.
Yeah, so maybe I can take that. So yeah, so what you said is true, that it is essential to resolve a service request as soon as possible, and and that automatically leads us to the solution that where if there is an expert, you'd like to leverage it as much as possible, correct? That whoever is an expert in a particular domain, you like to assign that person that particular kind of service request. But as we mentioned that in practice, what we found is that sometimes these expert people, they tend to leave. Okay, and if that is that is what is unfortunately what has happened, then you are left with less competent people when it comes to that kind of expertise, right? Because other people didn't have that exposure to resolve that kind of problem. So although expertise based thing is the first thing that common sense tells us that one should be doing, but in practice we have seen kind of it being counterproductive.
Okay, thanks. Alexander, do you want also to bring up your comment?
Well, my comment is essentially, I really like that you did not limit yourself to presenting things that worked, but also explicitly addressed the things that did not. And in particular, the discussion of expertise as opposed to seeing tickets as a learning opportunity, right? So I completely understand the point of Kunal that, once people who have expertise leave, right, the project the company loses knowledge, but says next step, and this is why we not only need to, do everything imaginable to keep the experts, but we actually need to invest in those who can become experts in the future. This is indeed, it might sound obvious, but I have never seen it before. It's a very good, very, very good point. So I really like it.
Thank you. I should just like to call out something that in the production, lot many work that we may encounter on the go, because in academia, whatever paper we publish, these are great, but mostly theoretical. But whenever we run that into the practice, when we deploy, we hear lot many comments that do this, do that, because people demand are never ending. So whenever we develop that, yeah, so we have deployed for 18 teams and we are looking forward. People are much interested in sport and they are calling it as a hidden gem. So we will explain and we'll give you some better scenario in the coming days.
Maybe I can comment on this. So several years ago, I've been working with people at Infosys, and the problem there was that essentially this ticket allocation was sometimes abused to stop the clock, to stop the SLA clock. So I was so essentially when people were saying there is not enough information, let's put it back on the user side, but in fact there was sufficient amount of information to proceed with handling. So I was kind of wondering whether this kind of undesirable behavior can or should be taken into account by the bot to keep an eye on how actually the work is being done.
Okay, so I can answer in two ways. First, because 18 whatever data we provided, these are the assignment and comment that feature, but there are other teams who have requested that if that ticket is there and there is no work, just stop their counter, but actually it impacts your productivity. So we had a discussion with the project management team and understand that is impacting our delivery timeline. So we told that probably that it's not a good practice. We can better put a comment so that why the counter is getting blocked, either the engineer who put a request is not providing you sufficient information, otherwise the engineer who is supposed to work does not have the necessary information to proceed. Any of them, that is lack of resource or lack of knowledge, any of them can be the option. So we have proposed that instead of turning off the clock, better poke both of them and their respective program manager so that they can unblock and take it forward.
Thank you.
Take one more question. There's none. I have one. I was wondering a bit, because you showed quite nice quantitative data that the resolution time decreased from the survey and so on. Did you get an impression what the most important factor was in that? So what made them faster in resolving the issues?
So initially when the tickets were distributed among the program managers or the scrum master, they have as a human, everyone has a biasness, so they used to assign someone more, someone less, and everyone have their own cycle. So people could not solve in time, and it was not an even distribution. Now when the bot comes, bot does not distinguish between person A and person B. It treats everyone equally. So it was an even distribution among all the engineers. So engineers got to see variety of works, and the work does not become monotonous for them. They have the opportunity to work on multiple initiatives raised by the service request, and by that they work, and if they find some issue, they have the option to collaborate with the other engineers to get it resolved. So by that, job satisfaction kind of also increased, and at the same time, as the number of tickets getting distributed, people solved quickly rather than one people having long backlog tickets.
Okay, interesting. Thanks. Okay, I guess we have reached the open discussion part of this session. So please feel free to bring up any issues that you saw in the whole session. So from our first presentation on the data set, the ground truth data set, the SAW bot, the machine learning model on identifying bot activities, and now our last presentation on the bot for the distribution of service requests. Any issues that came up that you want to discuss further with the authors?
Actually, I have a question for Mehdi. Yeah.
Sure, go ahead.
Yeah. Yes. So, typically in ML data sets, okay, when you distribute the total data set into training and validation and testing. So what I typically saw was that training plus validation was like 80%, and you do the testing on 20%. Okay. But I in Mehdi's both the papers, in one case the testing was 40%, and in the second one it was 50%. So I was just a bit surprised over there, right? So is it possible, like if you had made the training set data set larger, the proportion, that you could have seen a better result? That's
you mean the first study or the second one?
In both, basically. So in the first one, the test was 40%, right? And in the second one, it was 50%. So I'm just curious.
In the first one, it was 60-40, and in the second one, it was 50-50.
Correct. So
actually, the more data in your testing set, the more reliable your results on the evaluation of your model. Because, for example, if you train your data with 80% of your model with 80% of your data, your model will be more biased on the data, and it will have better results on the test data, or worse results on the test data.
Okay.
But,
yeah. So did you observe any such overfitting, like when you increase that training data set?
I didn't see any overfitting, because we use cross validation for validation of the training. So I didn't see any overfitting.
Okay, and I had a second question for you. So in your second work that you presented, so naive Bayes performed the best, right? So I was just wondering, maybe I have missed it. So the final solution that you deploy, is it only naive Bayes, or is it like an ensemble of those machine learning models?
No, it was naive Bayes. Naive Bayes got a better result, and we used naive Bayes. It was a research cross validation to compare between these models, not as an ensemble model.
I mean, do you think there is a scope, if you had used an ensemble model, that the result would have been better? I mean, typically that happens.
Yeah,
often.
It can be, but we didn't test it. Yeah, it can be always. Not always the ensemble model have better results, but you can have different model based on different aspects of the of your data. So and combine them, so you have better results.
Okay, thanks for the answers.
Oh.
Any more comments, questions?
think maybe I can briefly comment just on the previous discussion.
Go ahead.
So there was okay. So one of the reasons why Mehdi chose for just not for an ensemble model, but just one of the techniques was also because of simplicity. We didn't think that having an ensemble model that combined multiple techniques would actually lead to much better results, given that the results of these simple models were already very high. But there is, of course, still room for improvements, because for the moment, most of the results are based on just analyzing the comments, the contents of the comments. But like things we didn't do and that other researchers have been doing is also look like information that is outside of the comments, like how fast is the bot reacting, how are bots interacting with other persons. So this extra information is likely to lead to other results, but this would be combining our data about the contents of the comments with extra other data about how and when and on which basis the comments are being produced by bots and how these comments are interacting with others. So there's probably room for even further improvement.
Okay, I understand. Thanks for the answer.
I saw Ahmad raising his hand.
Yeah, actually, I have a general question to all of the paper authors in this session. So actually, we noticed at this session that some of the papers, they came up with their own approach to detect bots that used in their studies. So I'm wondering how much the difference would deviate if they are going to repeat their studies and using the proposed approach by Mehdi.
Anyone wants to comment? No? A comment there? Okay. Then let's move on. Any other questions, comments? I mean, I have an observation which I found interesting, is that especially in this session that we have quite a big spectrum of types of contributions, right? So we have from what we mostly expected, I think, in the beginning, that people propose bots and then do some evaluation on it. We had that here, and we have evaluations with controlled experiments. We have evaluations with more mining studies. We have now, which I also found very interesting, this the data set created, what Mehdi reported on the classification of bots and so on. So I see a big spectrum of things that are going on in the workshop, and I actually find it interesting. I was wondering if we have kind of standard ways to evaluate bots, because right now everybody's inventing his or her own way to do that. Do you think we are converging to something, or are we still exploring?
If you're talking about evaluating bots, in which sense do you mean evaluating bots?
In whatever, I mean, that's part of the question. Are there standard ways to evaluate it? What are aspects of bots that we find interesting or useful, or when is a bot good? I think that's a general question. Is it?
Because it's like, well, one of the things that we encountered in our studies, and that was actually in the beginning a surprise, was, so in the beginning we thought there's a clear, how to say, difference between bots and humans. And then we started noticing that you also have what Mehdi told in his second presentation about these mixed accounts, where you see these cases where there is a human person, a human GitHub account that is mostly doing normal human activities, but then there is apparently some automated tool that this developer is also using, and that is actually using his same account. So it's a mixed account because some of his activities is automated and another part of his activity is manual. And then actually, yeah, what is this? Is this a bot? Is this a human? Actually, it's both. So this is actually a case in which you have some kind of actor that in some of the times he's actually acting as a bot. Some of the time he's acting as a real human person. So this is something that was a bit unexpected to us, and it's not really like a local phenomenon. It's happening really frequently. The second tool that Mehdi proposed is able to detect this to a certain extent with lower precision than the previous study and the first study he presented. But still, this was a bit unexpected and interesting, because this shows that, like, okay, just having a clear-cut definition of what is a bot or when something is a bot is not as simple as it seems with this presence of mixed accounts. I don't know if this is something actually specific to GitHub, or can you also find it in other types of platforms, well, non-development platforms. For chatbots, I don't think you have something similar, but this was something unexpected and interesting and difficult to deal with.
Okay, maybe I can add, a perspective from the industry. So one thing that we found, to adopt something which is already there in academia, maybe. So one main challenge of adopting something which is already there is the license of the software. Okay. So for example, whenever we're trying to build something within Walmart, so that will require a rigorous, process. And whatever are the components that we are taking from open source or something, so those things have to be have a license which has to be somewhat compliant to our things. Okay, so I mean, I wasn't guessing this is something you thought that will bring up, but it is something we found in industry from which hinders adopting some solutions that are there outside. And the second point is basically the scale at which these softwares are designed. So for us, it has to be, at such a big scale, as the numbers may have given some indication, right? So, sometimes we have to adopt something and then throw away the backend, because we have to put in our own database, our own, search engines, and so on. So I think these are kind of the challenges, from adopting something which is already out there within an industry.
Thanks. I saw Eleni putting up her hand.
Hi, Stefan. So I just wanted to add something on top of what Tom was saying. Basically, we went into the mixed account level, but actually on that mixed account data set that Mehdi and Tom have mentioned, there is also the possibility of a mixed content in a single comment. Basically, you have some part of the same comment that could be bot and some that could be human. And that might be produced because the bot is reporting on some kind of human message in another platform. So this is yet still a challenge, right? So the deeper we're looking for this, we find even more challenges. But at least, and Alexander, please feel free to add something on top of that. It's, yeah, you always need to take it one step at a time. So I really think that, for example, with Mehdi's classification, it's one step ahead, but then going into splitting the content of the same message, if we really need this to go that deep. So I think it's something for discussion.
Yeah, so maybe I can essentially add that. So there are two things, right? So indeed, the bot can report some kind of human-based text. A bot can also ask for addition of text by human beings, for instance, on some kind of external platform, and then integrate this into GitHub issues. So this kind of things we've also seen. More annoying things when people respond to human to bot generated content, all kinds of mixtures. From, you can also have a situation when errors are being reported and human respond to them. So indeed, you have those, as Neil is calling them, cyber comments. You can have many different scenarios which are leading to this kind of cyber comments. Some of them we could figure out, some of them we could not. So you only can guess that it's a cyber, but you have no idea why it's cyber is essentially there. Going maybe back to Stefan's question, like when is bot good, when is bot not good? So at least in this Philips experience, what was important for them is just that it should be, it's actually just, it's a matter of user interface, right? That's what we've been evaluating. They've been very quite excited about this possibility of fixing these things on the spot. But at the same time, it was quite clear that, you know, you cannot just show them a wall of suggestions. It has to be integrated in their workflow. So that's probably not a big surprise, but it's nice to see how it can be done.
Yeah. Okay. Oh, and Mohammed.
Well, I think based on the discussions that we had so far and based on the presentation that were presented so far. So I think one of the questions is, do we need to detect like bots, for example, in the context of GitHub, or and how this impact the social acceptance of these comments in terms of for developers to take these comments seriously and being able to, for example, address of them some of these issues that raised by, we don't know, bot or a human. And also maybe, is there also a need for maybe an accountability model where we can decide whether these comments should be taken seriously or not? Should this be a mixed human bot interaction, or maybe another layer of bots that will decide which comments should be considered or not? Yeah, I'm just opening this as a fruits for discussion. Yeah.
Maybe I can comment on this, right? So essentially, when you're saying, do we need, the question is, who are we, right? As a researcher, of course, I want to separate bot contributions and human contributions, because I want to study social interaction between human beings, and I don't want to study social interaction between humans and bots, because it can be different, right? If I'm a maintainer, then maybe it's a matter of trust, right? If I don't trust a person, or if I don't trust a bot, people tend to be more concerned about bots, right? Or at least less interested in bots. Not clear, right? So it essentially depends very strongly on your perspective.
Yeah, well, I agree. I also I think it's well, I'm not questioning the need for this. I'm questioning the implications of this in terms of maybe there is need to detect them, but there is need also to classify them and being able to maybe filter them and being able to audit them in in a way that also increase trust in the comments that's generated by bots.
So we have some discussion going on in the chat about malicious bots. Diego, do you want to bring that up?
Yes. So I was just wondering if you have already some sort of reported cases where, let's say, a malicious bot would disguise as a human, would try to introduce malicious code, or try to Philippe mentioned mine bitcoins there as well. But I would also want to add, I think it may be important to distinguish between bots and humans also for collaborators, right? I do think software developers need to account for them differently. When it comes a message from human, a message from a bot, I'm not totally sure that we need to put them exactly on the same level. I think it might be also in the future that GitHub needs to sort of be more explicit about differentiating between those. So as collaborators of open source, you sort of know better where to look at it, where to really have to address a comment, or whether this is just like an automated analysis that's done by a bot. So I think that there was the malicious part there that I'm not sure if you have a case. Maybe someone has already seen this, but also the part that I think the interface and the collaborators, they need to know if this is a bot or this is a human. So that might better guide them how to reply to different actors. Yeah.
Okay, I see Tom having his hand up.
Okay, unmute. Yeah, there was just a topic for discussion. So until now, we have already heard about and seen several papers about what's the benefits of using bots, but there is also what is the drawbacks of using bots, because there's always the good side and the bad side. So one of the things I'm always asking myself, I don't have an answer, is, well, starting from when does it pay off to use bots, and when should you definitely not use bots? So what are the disadvantages of trying to put in place a solution based on bots? When is it actually cost effective? Every technology has its costs, and so I think we should also do more research on that. I would like to hear your thoughts on all of this as well.
Yes, definitely. I think that's also the direction I thought about when I asked my question previously. So how can we evaluate a bot also in the sense, does it make people actually more productive, and does this productivity pays off? Yeah. I think there's still a lot we can do.
So it comes about the ethics. So if we find that it is actually helping the human, because it all again judges upon us that what is our intention, whether we want to make people's life easier using bot, because you know in the airlines there are service bot, in bank there are service bot, but in production whenever we have the capability to use for malicious practice as well. We have to be considerate where we are using and what is the purpose the bot is going to solve.
All right, I think Mehdi, do you want to say something? You can.
Yes.
Please go ahead.
About Diego, what Diego asked, I think we should have a boundary between useful bots and I mean those bots that are only for information, or those that have those are doing tasks. Like for example, we have bots that are doing tests, bots that are doing code reviews and things like that, and we have bots that only, for example, onboard newcomers, like giving information to them, or we have stale bots that informs about the pull request issue and issue stale being a stale, and we have bots that so we need to discriminate between these two bots, these two type of bots. And as far as I know, that's why I think the way bots are acting in GitHub are different than in other social platforms like Twitter and Wikipedia. In social coding platform like Twitter, bots, the main purpose of bots are for propagating false news and things like that. But in
Hi everyone, let's start the third and last section of the workshop, Chatbots Design and Challenges. It's my pleasure to welcome Claudio Pinhanes to give the second keynote about chatbots design guidelines and how to best support their collaborative development. Claudio is the manager of the Conversational Intelligence Research Group in the IBM Research Brazil. His research is focused on conversational systems, artificial intelligence, social computing, and human-computer interface. Thank you, Claudio, for accepting our invitation. We are super excited to hear what you have to say. So feel free to share your screen.
So first of all, thank you for inviting me. It's great to talk to all of you. I'm not from the software engineering area, so what I'm going to try to bring to your conversation is my perspective as a researcher in AI, especially on conversational systems. Let me start trying to share my screen. You may hear in the background some birds. I'm in a sort of from my country home, sort of a rural area, São Paulo city. Can you see the screen? Good.
Yes.
So, listen, my name is Claudio Pinhanes. I I work at IBM Research Brazil. I also work in a center that we have with the University of São Paulo. I've been doing research in AI for almost 30 years now, different areas, but in the last 5-6 years, focused on conversational systems and especially their use in customer service contexts. But I think a lot of what we have discovered in that area apply also to conversational systems in other areas such as software engineering. And since that a lot more was probably done in customer service than in any other area in terms of use of chatbots, I believe there's a lot of lessons to be learned from that. But later in the talk, I'll try to address some of the possible issues I see in using chatbots in software engineering from the perspective of someone who works in AI and HCI, which is the main area of my research. Just to put the context, I'm part of IBM Research. IBM Research is a group of more than 10 labs, 3,000 researchers. We have a lab here in Brazil, in São Paulo and Rio, different campus. We have almost 130 people in total, just to give you the context, many different areas. I'm also, as I said, part of an initiative that IBM has with the University of São Paulo. We are creating a center for AI at the University of São Paulo. This is really something new. It also opens some other possibilities in terms of collaboration with other areas. And I believe at some point maybe in software engineering, given that there's a very strong group there, and even some of the participants here are from the University of São Paulo. So just before I start to talk and talk about what we have done, I want to make sure I acknowledge the whole team involved in the research. I've been here, include one of the organizers of this workshop. She's not listed here, Marielle. She worked with us for some time. She's involved in some of the work I'm going to present here. But this is a very multidisciplinary group that has been involved in all this research. And I want to make sure I acknowledge all the great work they have been doing in the last 5 years. So first I want to give a context where this research is happening and has happened, which is the very large and strong recent progress we had in artificial intelligence. And I think it's important to understand what has happened in the last 5-6 years in this area, because there is a lot of buzzwords, there is a lot of hype, but I think, in my view, the progress has been limited to one specific area, very important progress, but very specific area. And that constrains a lot of many things we can do and many things and also explain why some things remain so difficult. And that's especially true for the case of chatbots, as I'm going to discuss. So I like to define AI not as a technology, but as a class of problems. I think that's in my view, the best way to understand what we have been calling AI for the last 50 years. So in my view, AI is this class of problems where human beings are very good at solving, but traditional procedural programming has been not really good in solving that. And that include object recognition, natural language, most of natural language understanding, supporting people in complex knowledge tasks, driving a car, and many of the stuff that we have seen a lot of progress in the last years. So that's the area of of where that's the area of problems that we are interested in my view, in AI. But we have to understand that what happened recently did not cover the whole class of human solved problems. And of course we know, I mean, what happened in the last years is that since the 80s, late 90s, a lot of work on machine learning, and recently, especially starting from 2012 and forward, this whole boom of deep learning. And I think that this class of problems that deep learning solves, and even some traditional machine learning, is really a subclass of AI, which are problems that require the notion of similarity to be solved. So a huge problem for any AI algorithm before this was determining that two things looked similar. Two things that the boundaries of similarity between objects, between ideas, between sentences, between words and so on. And I think with this rising neural networks supported by special hardware, supported by many important scientific advents, that made this class of AI problems that deal with similarity solvable to an extent that 5-10 years ago we wouldn't be expected to be solved in so fast. So, but often the fact that this class of of problems that involve similarity, the fact that we can solve them now is seen as the fact that we can solve AI in general. And I think we are still far from that, and particularly that plays in problems involving language. And in this case, that we are going to talk here, problems that involve conversational systems. So the first thing is, have to be clear, is that, I mean, similar is not equal. And this is a typical example where people say, let's teach a computer to paint similar to Picasso, and then they show Picasso works, and they put a picture different, and he paints a Picasso picture, whatever that means. And what's the value of that? Is that right? Is that ethical? So whenever we start to use similarity in depth, and especially in our case, similar training with human data, we open up a lots of problems, and one typical one is the problem of bias, because the human data often that we use to train those systems.
So hi everyone, it seems to Claudio had some connectivity issues. So we are going to start the presentations right now. We can start the first presentation.
Hello everyone, my name is Liliane and I'm going to talk about the paper Towards a Question Answering Assistant for Software Development using a transformer-based language model. In this paper, we present an exploratory study of how could an assistant based on transformer could perform to answer automatically development-related questions, because developers search for relevant code examples on the web for their programming tasks. But there are three major problems. First, they need to read and analyze multiple results from the search engines to obtain a satisfactory solution. Second, the search can have problems due to a lexical gap between the query and the information associated with the solution. And third problem, the retrieved solution may not be comprehensible. For example, the code segment might miss a succinct explanation. And a relevant problem is related to ground knowledge, may not have answers for all questions. So we want to propose and evaluate a solution for questions that are not well answered by search engine. An alternative, we can use an assistant based on transformers, such as GPT-2. So we investigated the limitations on a model trained with the GPT-2 to support the capacity to generate English text and code snippets extracted from the Stack Overflow dataset. And what are the goals? We are interested in to understand how a modern transformer-based language model would perform on development environment. And we want to understand the limitations of the model towards a feasible approach. And finally, we want to evaluate the accuracy of the answers returned. Okay. And next, we are going to present the steps to perform the study. About the corpus preparation, we stacked the questions and answers from Stack Overflow to build the corpus. Initially, 20 million questions were recovered. In sequence, we selected only questions with the tag Java and English language. So we selected the 865 key questions and answers pairs with accepted the answers. So we use the fine-tuning concept of GPT-2 model. Fine-tuning, it is a pre-trained model in English. Here we have an example of question. The start of text and the end of text delimiters work as supervised training indicated the start and final of the text, and question and answer delimiters allow the model to learn the difference between question and answer. In sequence, about the model training, we used the pre-trained 124 mega model of the GPT-2 that makes it possible to learn the English language, and because large models would require more computational power. So we want to compare the answers produced for the two fine-tuned models. So we have two groups, how-to model and now how-to model groups. And about the question definition, we established some criteria to define the questions. First, we use how to, how can prefixes to compose the questions. Second, we choose simple text on popular APIs so we can more easily access the quality of the answer produced by the model. And about incremental questions, to increase the specificity of the context in the question, we propose incremental questions. First, from a generic question, we added information to evaluate how different could be the produced answers. So we consider questions. First, without context. In this case, we expect the model to suggest an API or class or method. 2. Containing class name. In this case, we expect the model explain to class and suggest the method of that class. Third, with a class and a method name. In this case, we expect the model to explain how to use that specific method. Okay. And to generate the answers, we maintain the prefix to specify how exactly the text must start. Example, question, how to open dataset connection. Next line, and the answer. And we limited the size of the answers equals to 250 tokens, and we defined only 5 answers or sample. And finally, about the results, the quality of the answers is not satisfactory, but they are answers that make sense when quoting classes and methods. And we could observe that the how-to model, when compared to the non-how-to model, was able to produce more contextualized answers, sometimes containing legible pieces of code and consistent explanation. One possible reason for that better performance may be related to the structure of the question. And we selected the posts that could contain the word how in any part of the text, and we observed that most posts started with the word how. And we can observe about the design of incremental questions has some difficulties in answering more generic questions. So we recommend to create specific questions. And the quality of the answers in terms of grammar is satisfactory for English language. Okay, and as a conclusion, in this paper we presented a preliminary study aimed at investigating the use of a transformer-based language model aiming the development of a question answering assistant. And we suggested that the corpus used in fine-tuning should be carefully designed, so the answers can be more accurate. And finally, as a future work, we are evaluating other language models, such as GPT-3 is a new version with more parameters, and DeepLove, it is a specific conversational assistant. So I finish here. Thank you.
Thank you so much, Liliane and Marcelo. Now we will open for questions. You can write your question on the chat or raise your hand. I have a quick question for Marcelo. Did you look at, or are you planning to look at Portuguese text?
Oh, thank you for your question, Marielle. Actually, because these models are already trained, there is a very intensive, the training is very compute intensive. So we could not make it for Portuguese. So we already used a pre-trained model for English. So no, the short answer is no, we have not planned for that.
Yeah, first, thank you for the presentation. Actually, I'm just curious a little bit. Why did you use GPT-2, for example? Why there are many transformers, for example, BERT, also they are using it as question answer tasks. So could you elaborate there, please?
Yeah, well, actually, we are planning to have different baseline models for comparing them. So this was a first initial work. So we did not have sufficient time to test different models. But sure, we could. I can say that we are now. We finally had access to GPT-3, and I can say that the results are very, very different. So the model matters, right? And the Pavlov, we already with some kind of based on a little bit on another transformer model. We did not have good results. So there is a lot of variation on on the models. Yeah, that there is, and it's good to it's a good idea to compare them more systematically.
Yeah, cool. Again, it's a very nice study and interesting. Thank you.
So, any other questions? You can raise your hand or unmute the microphone. So, Marcelo, what are you planning to do as future work for this work?
Yeah, as I mentioned to Bedell, I think, right? We're planning by the time that we wrote this paper, we did not have access to GPT-3, and 1 month ago, maybe a little more, we got access, because it was closed for just a few people to experiment with that, and now we had asked for access just a long time ago before, and now we got the access, and we are redoing all the work, and just to compare how much more effective could be using GPT-3, and the results are encouraging us, much better than GPT-2, and this is our current work right now, and just trying to check if those assumptions that we had to cope within GPT-2 model, we need to cope within the GPT-3. And our preliminary results show that it's a little bit different, although the results are more encouraging, and we are trying to look also for, because the results in terms of accuracy were not very encouraging with the GPT-2. So although they were not encouraging, we were looking at another kind of use for the answers that we've got, because in terms of semantics, they could even if the answer was not completely accurate, it was somehow related, and in terms of semantics that could, for example, help in information retrieval certain genes that we have already for Stack Overflow that we have been investigating a little bit for. So, for example, there could be another feature to improve information retrieval certain genes based on to capture answers from Stack Overflow, for example.
Good, thank you. Any other questions? No? No? So let's move on to the next presentation. Thank you, Marcelo.
Thank you.
Hello, everyone. Thank you for attending my presentation. My name is Ilham Qasi, and I'll present the paper entitled iContractBot, a chatbot for smart contract specification and code generation. This work was done in collaboration with Sharish Mishra and Mohammed Hamdaqa. Smart contracts are computer programs that are deployed on blockchain platform, and they are executed only if a predefined conditions are satisfied. The main features of a smart contract in blockchain is that they are immutable. This means that once the contract is deployed, it cannot be modified. Moreover, they are decentralized, which means there is no single machine that is controlling the smart contract. In fact, all the nodes in blockchain network stores the contract with exactly the same state. Furthermore, smart contracts enable blockchain technology adoption in many use cases, including healthcare, identity management, Internet of Things, etc. There are many blockchain platforms that support smart contract development, which are Ethereum, Hyperledger Fabric, Cardano, EOS, and many other platforms. However, smart contract development is challenging, especially to non-technical users such as stakeholders, as they cannot understand the code. This is further complicated by the fact there is many languages and platforms where each platform has its own terminology and syntax. To shed light on this challenge, this is a snapshot of smart contract code in two popular programming languages, Solidity and Composer. In this example, we are creating a contractual party patient for medical use case. Notice that the syntax and the terminology used to define the patient and its attributes are different. To define patient, we have used the terminology participant in Composer, while abstract is used to define it in Ethereum. This shows that there is a need for the users to know and understand the smart contract code and the blockchain structure, which is complicated. One of the popular approaches used to address smart contract development challenges is model-driven engineering. Model-driven engineering is a software development methodology that focuses on creating and exploiting domain models. Following this approach, we have previously introduced iContractML, a domain-specific modeling language for smart contract modeling and development. In this framework, we have used this model to generate smart contracts artifacts for 3 platforms, which are Ethereum, Azure, and Hyperledger Composer. Using iContractML, it will be easier for the users to understand and generate artifacts without the need to learn the syntax and the infrastructure of each of the supported platforms. However, it's not interactive and it's not seamless, as it does not provide guidance on how to use the language. Moreover, the contract creators still need to learn the model construct. A promising solution to tackle this issue is using Chatbot, where it can be utilized to facilitate non-technical users to use model-driven engineering tools and also to enhance usability and user experience while interacting with models. Hence, in this tool paper, we integrate the Chatbot application with the model-driven based framework iContractML. Moreover, we introduce iContractBot, a goal-oriented chatbot application to allow users, whether technical or not technical, to develop their smart contract in a gradual and interactive manner. The main goal of this paper is to create a conversational agent for model specification, where we have the conversation with the smart contract developer as an input and model specification as the output. Any goal-oriented conversational framework requires an entity recognition component to understand the user's goal or objective. Hence, the first component we have in our system is intention detection, where the bots classify the end user's input into one of the predefined intents. To link natural language conversation and modeling specification, we need to map the detected user intent to the model specification of iContractML. In order to provide this link, there is a need to identify the principal entities of the model and represent it as a key structure for mapping it to the captured user intent. The next component is model validation. In this component, we are performing input sanitization at the chatbot level and output validation for the created model before any model transformation. This validation is done based on a predefined rules that will enable the chatbot to handle incomplete or inconsistent elements defined by the user. Once we have a valid model, we generate the code using model transformation component. This figure demonstrates the implementation of iContractBot and highlight the main components of the framework. We have the following components, which are ChatKit framework to detect the user intent, validation entities, modeling service, and extend to generate the smart contract artifacts. There are many chatbot frameworks available to build conversational bots and to detect intent, such as Google Dialogflow, IBM Watson Assistant, and ChatKit. ChatKit is an open source framework that supports integration with the previously mentioned platforms to capture user intent and to understand advanced natural language. Moreover, this framework empowers building platform-independent chatbots. Hence, in this paper, we have adopted the ChatKit framework to build the conversational bot and to detect the user intent. The user intent is detected based on a predefined set of expressions or set of training sentences. The modeling service component represents the linking of the user intention to the modeling specification of iContractML. We have identified the principal entities of the iContractML and represent it as a key structure for mapping it to the captured user intent. The principal entities is a business process contract that manages the relationship between a number of contractual parties, which participant. The contract defines those parties and gives them privilege that are stated as conditions of who, how, and when a predefined process, which is transaction, is executed in order to change the state of thing of value to the participant, which is an asset. Asset can be anything that has value, such as goods, services, properties, money, vehicles, or real estate. The state of these entities are stored in blockchain. Using iContractBot, we have created models and generated deployment artifacts for a vehicle auction use case. In this use case, a smart contract is used to auction vehicles, where the vehicle is the key asset. There are two participants in this example, owner and bidder. The smart contract is created by the owner to auction his or her vehicle. The bidder can place bids on the vehicles that they are interested in. This is the DSL instance model generated for this use case. As you can see here, we have the main classes of iContractBot, iContractML, and we have mapped them to the user intent to create the auction vehicle use case. This is a video that shows the conversation used to create the vehicle auction use case. This is a sample of the generated code in Ethereum. As you can see here, we have the contract vehicle auction. We have two participants, which is the owner and bidder, the vehicle as the key asset, and we have the two function, which is place bid and withdraw. In conclusion, in this presentation, we started by explaining the need for more interactive and easier way to enable the non-technical people from composing and creating smart contracts. Hence, we have proposed the use of chatbots in order to generate smart contract artifacts. Moreover, we have presented the architecture and components for our model-based chatbot for smart contracts, and we have showed by example how it can be used to create smart contract for vehicle auction use case. In this tool paper, we present the framework and the components. However, we have omitted many of the technical details that will be highlighted in a subsequent work that is currently under consideration for publication. That's the end of my presentation. Thank you for attending.
Thank you so much for the presentation. We have good news. Claudio was able to join us again. And since we started the presentation, the previous presentation, we will finish the presentations and then come back to Claudio's keynote. Okay, so thank you, Ilham, for your talk. Do you have questions? I have a question for you. In the paper, you mentioned some future steps, like you mentioned that you are planning to conduct an empirical study from multiple perspectives. So are you planning to evaluate the bot? If so, how?
Yeah, thank you for the question. We already start evaluating the iContractBot by doing user experience survey. So we try to give them tutorial on how to use the chatbot and give them set of questionnaires to ask about their experience while using the chatbot and how it was like the ease of use and also the functionality of the chatbot. Moreover, we wanted to try also evaluate the iContractML. We had a graphical interface there, and we tried to see like which one is like it's easier for non-technical user to interact with. And also if there's any, like for initial results, it's good to have a combination chatbot and also some graphical interfaces for the user to interact and build their use case. So we're trying to evaluate it based on only using a model, interacting with the class diagram, also interacting with the graphic, and also interacting with the iContractBot. So this is what we are trying to do, and we already start doing it.
So these are the multiple perspectives.
Yes,
okay.
That's what we're trying.
So, Khaled.
Thank you so much for the presentation. It was quite interesting. I actually wanted to ask about more of the training side. So like when training this chatbot, did you generate your own data? Like as you as the developers, did you generate the data to train the model? Yes?
Yeah, like at this level, we were using ChatKit and we were using training synthesis.
Okay.
To detect the intent that we have certain of intents, which is the participant, the asset. So what we have done, we have generated our own training synthesis to detect the user input. Okay. But I think we need to add more synthesis so it can be detect exactly like to have better accuracy when we are trying to detect the user intent.
And another point, so in the future.
But for now, yeah.
So in the future, if you plan to use the user inputted data, like the user input as training, is there kind of privacy concern if you're like generating a contract? How would users agree to like share their data with the application if they wanted to, like if you as a developer want to use that user input to train the model, but then maybe they would have some privacy concerns. Do you have an idea how to like kind of handle that?
We don't think up to this level. What we're trying to do is like maybe we're not using their own input, like what they used to create the contract, but we're trying to create our own data set based on the intents that we have. And so this is what we are trying to do now, not like use the user input.
Okay.
But maybe we can think about that one and see how we can think about the measurement of the privacy of the users.
Perfect. Thank you. Thanks so much.
Thank you for your questions. It's a good question.
Marco?
Yes, I have a question. I noticed that you use some expressions like, wow, good job, you are almost there, that to encourage the people to continue to use the chatbot, what I really liked it. But we were discussing in the previous section about not being annoying or bugging too much, or about noise. Marielle has a work about noise. So what's the right balance of those encouraging messages, and how did you design those clues to the user?
Yeah, for right now, like we try to, as you mentioned, we try to encourage the people and see like, as we mentioned, like, okay, this is the only last step, great job. But once we conduct the survey and see how the user interact with the chatbot and whether they found it annoying or like they want less text to read or less text to type, then we try to adjust based on the user survey or the results that we got from the survey. So far, some users, they complain about the amount of the typing. They suggested to have drop-down lists. They suggested to have also from like the amount of the text that the bot trying in the conversation, they suggest to have a little bit, not like long sentences, to have a little bit moderate into point sentences. So we're trying to see like get a full input or full idea about the using the survey or the evaluation, and then try to apply it on the chatbot that we have right now. But we want to sense like what the users think about the current chatbot and then modify it.
Yeah, that was great. And we did recently a survey of social characteristics of chatbots, and indeed, it's not only the technical part that we need to get worried about. There are a lot of social clues in the conversation design that we need to get worried. So yeah, good job that you did that.
So thank you so much for the questions. Do you have any other questions? No. So thank you, Ilham. We are going to move to the next presentation, the last one.
Hi everyone, and welcome to my presentation on testing challenges for NLP-intensive bots. The success of artificial intelligence has sparked a substantial interest in the software engineering field, as AI applications face common challenges in their software engineering processes. Among those challenges, they are especially hard to specify, test, verify, and debug. This is even more problematic for NLP-intensive bots. We define NLP-intensive bots, or NLP bots for short, as software bots where the processing of natural language text is crucial to the bot's functionality. NLP-intensive bots typically rely on intent-based NLP engines to understand user inputs. Intents are a class of events representing the user intention in an abstract way. They are defined through a dataset composed of example sentences, which are used to train the underlying NLP engine. For instance, to show you a concrete example, let us assume we have a bot with a greetings intent that represents the different ways the user can greet the bot, such as hi, hello, and good morning. We define these possible ways to greet as training sentences for the intent. These alternative formulations for the intent will comprise the training set to teach the NLP engine what type of user utterances should be matched with this intent. Also, if a different input text is given, the NLP engine will classify it as other intent or as a fallback intent. An intent can also carry parameters, which are contextual information automatically extracted from the user input. A parameter refers to an entity, which can be a preset type managed by the NLP engine, for example, a city name, a date, etc., or user-defined enumerations, for example, a list of products available in an e-commerce website. Intents produced by the NLP component are typically integrated in a finite state machine. That could be as simple as the song or as complex as we want. This state machine describes the box's reaction to a given intent, but also the sequences of in-text reaction that constitute a conversation path. Despite the importance of NLP-intensive bots, few tools and research initiatives tackle the problem of bot testing. The big players, like Microsoft Bot Framework or Amazon Lex, provide facilities that can be used to define simple tests for individual intents, but there is no support for more complex text. This gap is slightly covered by some other commercial and open source tools. BotSE is an open source chatbot testing framework and a commercial service, especially targeting what they call conversational flow testing, that enables you to record and store a chatbot session as a test to re-execute in the future, mostly for regression testing purposes. Chatbot Test is an open source guide, rather than a framework, for testing chatbots, which is complemented with a Chrome extension called Alma, that provide guidelines for chatbot testing in Telegram and Facebook Messenger. Qbox is a commercial product focusing on testing training datasets to identify whether a chatbot identifies the correct intent for a given input. Dashbot is more of a dashboard analytic service for bots that help visualize, for instance, where the bot is failing to respond. Paraphrasing is another promising approach to test diverse inputs. Note that most research evaluations study the NLP component in isolation, ignoring the required interactions between this component and the rest of the bot and the external services it communicates with. As we will see in the following section, these tools and papers are a first step towards a complete NLP-intensive testing solution, but so far they cover a small fraction of the full spectrum of the bot testing needs. In this work, we adhere to the classification of the SWIBOK to discuss how this topic must be adapted to deal with the particularities of testing NLP bots. Due to time constraints, the categories marked in bold are the ones we are going to focus on this presentation. Unit testing, in this case, is making sure that An individual intent has been trained with a proper dataset to match with the user utterances is supposed to match. A basic unit test passes if all testing sentences produce the expected match for the tested intent. A more basic unit test should include checking that the uterus entities have been recognized and matched to the intent parameters. Integration testing has to check that there are no overlap between intents that could deteriorate the individual intent matching due to intent definitions being too similar. A correct set of user inputs should move the bot to the expected state in the state machine, as defined in the bot's conversation flow. In this case, if the user says hello to the bot, it will activate the greetings intent. In that case, the state machine will move to the say hello there state and return to the awaiting input state. In this other case, if the user asks for the weather in Barcelona, it will activate the weather intent, which will move the state machine to the answer weather state and then go to the awaiting input state. Acceptance testing has to check that the NLP bot behaves as expected by the client, which is especially relevant as the NLP definition is under specification. We need the client to validate that the learning process actually produces a bot smart enough to understand the idea its users want to communicate. In this case, the user is asking the bot for the weather forecast in a city. If the bot doesn't know what the weather is, it fails the acceptance test for this user. But in this other case, the bot answers the correct data requested from the user, so it passed the acceptance test. Performance testing requires simulating a large number of concurrent users having conversation with the bot. As such, it is not just about load testing the access to the platform, but generating sets of input text that will properly trigger bot conversations. In this case, our bot hangs when handling a lot of users, so it fails the performance test. But in this other case, our bot is able to respond to all the users, so it passed the performance test. Recovery testing should at least test whether, after a crash, the bot is able to recover the conversation at the state where it was before to minimize the crash impact on the user experience with the bot. So in this case, the bot is restarted and it started again the conversation with the user. So it fails the recovery testing. But in this other case, it was able to remember the question of the user and answer it properly. Boundary value analysis is straightforward when intent parameters are enums, but has the well-known challenges of detecting bounds when parameter types correspond to predefined data types. There is an additional challenge, which is dealing with the frequent at any parameter, that in principle can match any substring of a user utterance. As such, this type of parameters may fail because they match the wrong word, but also because they match the wrong number of words. In this case, as the user input is what is the weather like in Barcelona now, and our parameter is at any, the recognized parameter is Barcelona now. If we change this parameter to at city with the same user input, we will recognize only Barcelona as our parameter. In regards to coverage, we have two main metrics, which are intent coverage, which is the ratio of intents matched at least once during the test. In this case, if we test the greeting intent using the inputs hi and hello, we will have 50% of coverage of the intents. The other metric is inter-parameter coverage, which is the ratio of intent parameters matched at least once during the test. In this case, if we have to test the parameters of the training sentence, in example, what is the weather like in city, as in this case we have tested 2 out of 3 parameters, which are Madrid and London, our parameter coverage for this sentence will be of 66%. So, to conclude, we have seen the many specificities of testing NLP-intensive bots, mixing classical software testing challenges with NLP AI-based ones. Most of them are still open research challenges for the bot community. We hope to see continuous efforts in this area in the near future, and believe this work can be helpful to characterize them. Many of the open problems in software testing, such as test suite reduction, periodization, flaggy test, or diversity, are also of interest here. Well-known testing techniques in other domains, like A/B testing, could be also applied to bots. Beyond the suite of properties, some testing concepts more specific to NLP-based interface may need to be considered. So that's all for today. Hope you enjoyed, and I'm looking forward to answering your questions.
Thank you so much. Do we have questions? You can raise your hand or ask in the chat. No? Okay. I have a question. So my question is, your work is focused on NLP bots, right? But how do you see these challenges or similar challenges related to tests on other kind of bots? For example, bots on GitHub, the bots that were present in the first sections, for example. They are similar, they have similar challenges, or no?
For the moment, we have focused only on chatbots because in specific in intent-based chatbots, because there are some specificities on the way to test every single bot. So for the moment, we have only focused on that.
Thank you. I saw that there. Okay, Ahmed.
Yeah, maybe this, first of all, thank you for the nice presentation and actually a nice study. I think testing the chatbots in general is very challenging. I have a general question. So do you think, for example, including more aspects than in testing the natural language, such as, for example, the speed of responding, for example, even the quality of the returned sentences, you know, so for example, as we saw in the, I think in the previous presentation where there is a question answer generation, do you think even also to test the quality and the sentiment of the chat of the generated message is worth to consider as well?
Of course. In fact, we have covered a specific tech for human interaction. There are some work out there that we want to also put in scope, because it's important that the users want to use the bot. Not only that is the fastest and the better, but also that the user is happy with the bot. So if we have to take that in account too.
Thank you.
Thank you.
Thank you for your presentation. It was very nice. I have a question regarding, for example, the acceptance test. So when we compare the test from different contexts, as we saw in previous sessions, people have different expectation from bots, and they have different level of tolerance of the output come from bots based on different scenarios. And like Diego had a comment about in the Binda bot, in security related pull requests and things from bots come, like people respond more, while we see in other papers they have longer response date and different reaction. So do you think this something should be considered when testing the bots? It's what the context that we are testing, what the level of the expectation from the users or the clients of that bot.
Yeah, an acceptance test, in my opinion, could be as basic as it works, but I think it has to cover the user expectations. So as you said, if when you program a bot, normally you know in which context it's going to be used. So I think you have to have in mind which is your public or the people that is going to use the chatbot, in order to be better to these people, so they will be more satisfied with the chatbot in general.
Thank you.
Thank you.
Nice. We have time for one more question. So we have one question in the chat. Neil, you can.
Yeah, my question was about if you're doing this for, say, customer service, for example. One thing you could do is just measure how often the interaction fails and someone says, give me the human so I can talk to that person. So maybe, you know, you just write something, release it into production, and just monitor how it's working. So I'm curious where you think that trade-off should be. Like, how much upfront analysis do you need to do versus just letting it, you know, do A/B testing, for example?
As we use a platform that is dependent on other platforms, in this case, Dialogflow, IBM Watson, that services can change anytime, and you don't know. So you have to test if the chatbot is properly working when it's in production, because a barely change in some of the platforms can broke the chatbot completely. So you have to make an A/B testing, but also a continuous testing while the bot is in production.
Yeah, Jordan?
Yeah, just to complement to Neil's question. So I think that it's two sides of the same coin, in the sense that for sure we need to validate that the bot is actually responding to what the users are asking. And this is something that you can never predict, right? So you can create your bot, but then the user will always surprise you by asking questions that you never thought they would ask, or by asking the question that you had already expected, but that they phrase them in a way that you had not foreseen, and therefore the bot is going to fail. So this validation part is for sure needed as well. I think that this comes after a kind of a, if you want, verification or testing. That, for instance, you check that the state machine is behaving correctly, that there are no dead ends, that the conditions are consistent, and so on. Right? So it's complementary.
I guess just as a follow-up, how much, because you do some of this in practice, how much of the interactions are totally unknown unknowns, like requirements that you couldn't have anticipated ahead of time? Like, a lot of it would be like, I want to know how to get in touch with, you know, what's the phone number, or what's the price of X? How many of these interactions might be totally unanticipated?
Yeah, I don't have the concrete number, but for sure it's kind of a typical curve where at the beginning you have many of them, but then at some point, if you stick to a given kind of a e-commerce domain, in the end there are not so many, right? So typically what you have first weeks where the bot fails a lot, and then basically you stabilize it, and at some point there's more than questions, it's more the trolling, that it's always kind of they're more original trying to troll your bot, and this is even more difficult to control.
I see, thanks.
Great. Thank you so much for all of the questions and discussions. Now it's time to come back to Claudio's keynote. Right? Thank you, Claudio.
Hi, I'm sorry for my connection problems. I lost completely connection to the internet here. But I guess in the past, in workshops, you'd say, "Oh, we're not able to go there because I got a delay in my flight." Now it's the equivalent is my internet has went down. So let's continue what I was talking about here. So if you remember what I was talking that. Most of the advances in AI recently have been happening in this class, which I called similarity, of problems that involves finding things that are similar. And I think this has very important consequences for how we understand the design of chatbots at this moment. So let me go forward and saying, let's look at where's the state of designing chatbots right now. And I would argue that's a mix of art and science, and art in the sense of people using common sense or traditional ways to do interfaces and apply them to chatbots. And there's a growing body of knowledge of how that should be done. But an important issue is that when we think about how bots are being built, and especially in the context of customer service, where they're being built by companies using packages from other companies, most of them are created using this intent action systems, where you define intents for possible user interactions, and to each intent you associate an action or the text to be generated in that context. And it's important to observe that most of the impact of AI has been in the first part, in the intent classification. The whole process of generating dialogue from what's recognized as intent is still often in those systems quite a lot of hacking. It's in the sense because most of the systems are designed to be Q&A systems and not real dialogue systems. So it's hard to program how things should follow each other, how you should recover from unexpected utterance from the user and so on. Okay, so and in fact, when you look, most of the guideline part of chatbot development is focused on the second part of how you should generate this text. There's a lot of guidance out there about this. Unfortunately, most of what's out there, what's I've seen, and I'm not saying specifically of this book, but in general, is not really based on scientific evidence. It's more based on practices that people believed helped them to build bots, but there's still very limited science of how we should design bots. And what I'm going to do now is review some of the stuff that my group has been doing as a way to discuss some of the issues that we still need to understand more. And the different aspects that have to be researched so we can actually do a comprehensive and reliable set of guidelines. So let me start by an example, which is this work we did recently, in fact. This is work, I would say, in terms of the kind of language a bot should use. And we looked into should a bot use formal language or informal language? Okay, and I've seen guidelines for both. Okay, so what's important here is that we designed a study to verify that and understand how that should look into how it impacts different elements of the data. In general, I think this kind of study, you have to be very careful about the design of the experiment, because it's easy to prime subjects to answer whatever you want. So in this case, for this study, what we asked people to do was to look into different pieces of dialogue and say, which are supposedly not true, spoken by different candidates to the same job, and say which candidate is better. And in fact, I was comparing the use of formal and informal language in those situations. Okay, so by using these indirect means, we can have much more reliable answers. And in this case, what we found was that formality, in the case of customer service, seems there's no general preference. That it depends on what kind of goal you have. You want to make your bot. If you want to make your bot look professional, you should use formal language. If you want it to be empathetic, you should be using formal. and so on. It depends. The answer, it depends what you want to achieve. And also we looked into if this should be used differently, formality should be used differently depending on the type of question. And we found that, well, when you are communicating steps or making official, it should be formal, not much else. But this is the kind of study that has to be done more to understand key aspects of design. One of our first studies were even about very small details of visual design. For instance, in this case, we look and say, do the type of font that you use affect how people perceive your chatbot? And in fact, in this study, which is published at Chi in 2017, we show that if you use a font that looks more machine-like, people think that they are talking to a machine. If you use a font that's human-like, like the one on the right there, people think they are talking to a person. So it's small detail affect the whole perception of a bot. And we should be very careful about design and the visual design of the bots. We did a study about an exhibit that happened here in Sao Paulo, where people could ask questions to artworks using speech. So they would go in front of this artwork. They could ask any question they want. The system would recognize. We would put that in, try match to different answers, and give the answer back also in speech. And what was interesting is that when we look at what kind of question people ask, almost all questions, 60% of them, independent of the artwork, independent of the style, independent of where the artwork was in the exhibit, all was about meaning. They didn't ask about facts. They didn't ask about author. They didn't talk about the style. No, they want to say why the artist did that. Why? What's the meaning of that choice? In many ways, they asked questions about things that they cannot get visually. And we think it's very interesting that they use a different channel, or the auditory channel, to ask for one type of question, and they use their visual channel, their eyes, to look at the artwork itself. So we think this study just tells us a little about this balance that you should have between auditory and visual interfaces, and how your chatbot sort of navigates that space, in the sense of which channel of human interaction you want to use and what's the appropriate conversation chat. Another work we did was regarding the use of a single bot versus multiple bots in a chat. So we developed this bot. This is in 2015, very early work of our group, where this is a finance bot. You try to find recommendations of how to invest money. And we tested a design where instead of talking to one bot, you talk to multiple bots, one of which was an expert in different types of investment. And they would talk to all of them at the same time. We had a system to control their use. And we tested a single version versus a multi-version. And what we found was that the way people use the two different types of systems, the multi-bot, was different. And the people who use the single bot version tend to be more deep in what they look for. And they explored less the multiple options, while it seems that having multiple bots sort of prompted people to explore more on the breadth side in different options and so on. This is very interesting, and it's a design that we don't see much out there, but has this it seems to point towards engagement models which allow more exploration of the space, and it is in fact very interesting. We also have done some recent work with professional developers of chatbots. We're doing sort of ethnographic work on understanding how they built the systems, what kind of, how the building of chatbots happens in professional settings. And we saw a couple of things that it's interesting, sort of, they are sort of obvious, but people who develop technology for chatbots tend to ignore them. At least is our experience in our company. One thing we found is that it's a very collaborative effort of very different people. You have developers, you have curators, you have marketing people. For instance, we found bots where people were not allowed to generate any piece of text without okay from marketing. The marketing defines the voice of the bot. Okay, there's also it's the involve SMEs and the executives, and one thing we found in common was that platforms, they give you very little support for this collaboration, very little, for the different types of collaboration, the different needs and different kinds of experience of the people. This is work that we touched in this paper in CHI this year. We are submitting a larger version of that. This points, in my view, for still many open questions in the HCI of bots, of how to design bots. But also there is something that's coming for the next generation, which I briefly touched in this paper of Kui, which are listed here. I mean, for the because of time, I'm just saying, going through two of them. One is, we still struggle a lot to manage the precision of the language, to understand that some answers have to be exactly precise. If the person ask about, will the fee of this credit card transaction be waived for me? It has to be absolutely precise in the answer, because it's a policy of the company. But there are more generic questions that don't need it, and it is balance of managing this language. This is something that we still don't see in a lot of those systems. In the case of speech-based systems, there is this big annoying things that we have to call them to talk. Alexa, what do you think about that? Siri, what do you think? They should know when to speak. People know when to speak. And getting rid of these vocatives is a major challenge for next generation chatbots, especially if you want the dialogue to flow, especially if you want them to play in a collaborative environment like software engineering. Which sort of leads us to some reflections I want to talk about how to use language assistance in software engineering. And one thing is this issue of the software engineering, evaluating things already hard to do in general for any, but many things, now we have all these design options, all these design options. How we are going to explore this well and evaluate yourselves in this context? And I think it will be very hard. It's very important, but it's very hard, but we should keep in mind all the difficulty. There's another aspect which my work have been touching more recently, which is this notion that when we talk about software, we often have two elements in the source code, right? One is the code, and the other is documentation. One is the part that the machine reads. The other is the part that machine doesn't read. Okay, and of course, if you want to do software engineering, understanding the code part is important, and it's often the focus. And I just want to tell you about something that IBM just did, which is it's called Project CodeNet. It's just released 14 million samples of code labeled and in different languages. It's an impressive amount of open data to do understanding of code. And I'm not sure all of you, this is 2 weeks ago, all of you were aware of this. And it's a very important resource that's out there at this point. But going back, it's interesting because documentation is something that's put there only for human beings, right? It's so humans read code and documentation, and the system only reads code in most cases. And if you want to have software engineer chatbots, well, if you want them to help, they will have to read the documentation too. You have to look into that part that is for humans, because a lot of the collaborative information is there. And the good news is natural language processing is a point where this can be done much more effective than some time ago. The hard news is that people are very cryptic, they write very dense documentation, which it makes a lot of this work, a lot of what we're doing in NLP today, which is similarity based, makes it much harder to do well than normal language. Okay, but anyway, it's a very important area in this. And to close this presentation, I just want to go quickly to a recent work where we have looked into this issue of documentation. We try to understand documentation, not to help the developer of a conversational system, but to improve the running time of the conversational system. And I'm going to be very quick about this because the time is running out. This work we published recent at Chi, last year a little at NLP, and there's going to be a paper in ACL. So the goal here is is making the machine read documentation and extract something that's useful for the system that has to be run. Okay, and we did that in the context of chatbot development. And interesting enough, often chatbot development has very, very little space for documentation. And for instance, this is Watson Assistant, maybe a Watson Assistant. The only place, the two places you can talk about, write anything that's documentation is in that line called description and in the name you give to intent itself. Okay, like when you, it's a field that's similar to the name of a function or a variable in traditional code. So what we discovered was that, in fact, people use that the name of the intent, which is a 256 character field, to write a lot of documentation about what that intent is, about who did that the last update. Sometimes they include other comments with problems and so on. And in many ways, you should look at this. This is similar to some extent the way people name functions, they name directories and name variables and so on. But what we found in the case of chatbots, it was widespread use of a taxonomic structure inside this name IDs. And what you see on the right is the taxonomy we extracted from only this little field called name ID. And what we did, and I'm not going into details here, is instead of using a standard machine learning classification like the one on the right, we sort of used an idea that comes from zero-shot learning, and we embedded this information that was in the name IDs as in a space that was used as a new output space for machine learning. By doing that, we improved a lot of the performance of some intent recognition systems, especially the detection of out of scope systems. Again, I'm not going into details here, but the idea is that there is information about meaning hidden in documentation. And this has to be used by the chatbot. I mean, we've shown that it has to be used by the system itself, but how much that we can extract that from the chatbot, from the source code, and make the chatbot more knowledgeable, better, or even build it more automatically. That's what I'm going to get. And I think that's the message is, if we still have a lot of learning in terms of design guidelines, especially for action, we have to be scientific about this approach. We have to do experiments. We have to find experiments in the term. And I think in software engineering, we need to understand code and the documentation to really build useful collaborative bots. Thank you.
Thank you so much, Claudio, for your awesome keynote. I thought it's really interesting that you brought a new perspective to the community, a perspective from the HCI community to us. So thank you so much. And also, it was really nice to see how the simple details like the font of the chatbot impact the perception of the user. So it was nice because in this section we had like, in the entire section we had, for example, talks and the papers presenting the technical side of chatbots. So we had challenges in the implementation, papers talking about the implementation of bots, and then papers about testing bots, the technical side of testing bots, and then your perspective related to the design of these chatbots. And now I will open up for questions. So feel free to ask questions to Claudio and also to the other authors of this section about chatbots, challenges, and so on. Let me see. So we have a question in the chat. Neil?
Yeah, thanks again for the keynote. It was interesting. I guess my question overall is whether aiming to be more human sounding is a good goal or not. I often find it odd that Siri tries to appear human. Like, I guess my question is really, maybe that's a design goal, but how do we manage that spectrum between just do what I ask you to do and I don't care that you are sort of trying to be human, versus, you know, I want to pretend that this is an actual, you know, human on the other end of the phone or at the other end of the chat that I'm having. Where do we draw that line, and how, you know, I guess to just expand on this, you know, in animation, we have this uncanny valley, right? Where if your animation is too close, but not quite perfect, it looks really awful. Like that Tom Hanks movie. It seems like we might have something similar in chatbots where it seems really human, but it's uncanny enough that it's actually irritating to people.
I think this is a great question, and I don't think anybody knows this answer. I think that's one of the big answers in terms of HCI of chatbots at this point. I think most evidence right now points to it depends on the context. Okay, that if you and when we say context, it's not the task, but also at the temporal context. How often you have been using, how often, how integrated it is to our task. I mean, I sort of covered that briefly in that notion I mentioned before. Right? Well, I didn't talk in that this notion of pigeon, the fact that pigeon is a language that two people create when they don't speak the same language. Okay, and it's known from it's common. I mean, in linguistics, I mean, being observed in many situations with people from different cultures which are in the same space. But I think there's something similar happening when people talk to a chatbot for a long time. They start to figure out how they can be understood in a language that's not human. If they instead of asking what is the time of the day, they discover that if they ask Alexa time, it will answer. And suddenly they are talking to this bot in a very non-natural way. So the question is, if you start talking in a non-natural way, should the bot still be natural or not?
Right.
And maybe you have to change that. I mean, you have to see how your user is interacting and adapt to that. But I see the value of that in the beginning because it gives you a known frame of reference to the users. Okay, oh, It is like a call center. So they have this first impression interacting with many of the chatbot. But after a while, it becomes a different language, and often the bots do not adopt. So I think that's one of the differences. When it comes to software engineering or any professional chatbot, that's going to get even more complicated in my view. Okay, but I think the answer for this is we have to develop much better technology for the action part than we have now. For instance, we need to have simple ways to say, given, suppose I write, this should be the answer to your question. And we should have technological ways to say, make it more colloquial, make it more formal, and that's automatic.
Mm-hmm.
And then it's easy. Then it's going to be easy to adapt the chatbot to what's going on. If someone has to write 10 different versions of the answer to satisfy all these different contexts, it's not going to happen. So
yeah,
there's technology generation there.
Like
yes.
Humans are actually pretty good at that, right? And figuring out, okay, I'm talking to other academics, or I'm talking to a doctor, yes, or talking to my family. You probably adapt pretty quickly, I would think.
Well, we can look at two ways. We are very good, but we spend 10 years learning that at least, or more. And whenever we go to a community, we also spend some time learning how to talk at that community. So we understand the value, we have the mechanisms, but there is a learning process there. And this is still far away from our technology, again, for action, our technology for intent. It's an issue of a lot about similarity. Work is great. Action is about planning, is about balance between levels. We're still struggling there, my view.
Thank you.
We have more questions in the chat. Marcelo.
Hi, Claudio. Thanks for your talk. Very great talk. I think my question is still related with what you're talking about with Neil. And coincidentally or not, my question to the first keynote in this was something, maybe the same question that I have for you. And when you talked about single or multiple chatbots to interact with the user, I was wondering that about how you showed explicit different multiple bots, but what do you think about an implicit bot that would assume a personality that he could be a super bot that knows about everything and could answer about everything, instead of more specialized expert bots to interact with the user? What do you think about that? Would be it depends, or the generalization of an expert in all things, or more specialized expert bots?
Well, I think the first part of sort of this issue is related to the fact that we often interact with people from the same organization with multiple roles in multiple contexts. Okay, so and that helps because we understand that people have different goals at different times. So I'm going to give you an example, which in fact is a study of a human call center from probably 5-6 years ago. This is about, it's a healthcare provider, okay? And one thing they figured out in testing with human beings was that the same person who denies you a claim for an expense cannot give you advice on how to get better. Because the first one is an advocate for the health provider, the second one is an advocate for you. And people get confused with this double role so in this case it was a call center, which there are these two different roles that are in fact assumed by the same people. So I say, okay, I'm the call center. I'm getting a call. Oh, I should be the nurse in this sense. You're the advocate of the call. And if the person says, "Is this covered by the healthcare provider?" Say, "Let me talk to Maria," and there's another person on my side who's going to answer no or yes, depending. But often they would swap these roles if needed. But they found this is what worked much better, because then it would help people to navigate this. Okay, now we have machines trying to do this. First, I'm not sure in terms of engineering which is simpler to build, a single bot that takes different personalities or multiple bots. Okay, and I think this is a question, in fact, for this group. What's simpler to build? Okay, I've seen people building gigantic bots that take multiple roles. It takes some advantages. It's easy to reuse some common questions. It makes at some point navigation and the management very complicated. So that's one of the trade-offs. But the question which I think it's interesting is, it has to do a little with what Neil said, is how much the user is going to see those different roles as having really different interests. Because if you cannot pass that as having the same distinction as I said, of the nurse and of the healthcare advocate manager, let's put it this way. If people don't perceive it this way, then all the work of multi-bot is lost. What we found in our study that there seems to be some difference. People perceive them, even when they come from the same organization, as different. But I mean, this it's interesting because it's an idea that I've seen so little application in the real world so far. That's hard for us to see how that works. But I can see, for instance, when you think about software engineering, that is maybe thinking about a bot that understands the language, another that understands the domain, may be helpful for the user, and more important, maybe that the bot that knows the language comes from one provider, maybe the provider of the compiler or whatever, and the domain comes from a client and so on. So maybe an issue of containing organizations in terms of software engineering, more managing different organizations than anything else. Okay.
So we have one more question. Mohammed?
Yeah, well, very interesting talk. Thank you for the talk and for the insights that you provided. It's really nice and helpful to see it also from someone who worked on this for a long time now. So I think also one of the interesting topics that you mentioned, and it's really exciting, is how language is evolving over time and how technology is changing the spoken language that we have today. So in fact, this is one of the discussion that I teach a course in emerging technologies, and this discussion pops up in several sessions of the course where we normally the effect of the technology on our spoken language, our natural language, and where we're going from here. In fact, one of the examples that I give normally is that for my daughter, the youngest one, one of the first words that she used was "Okay, Google." We were in the car, and she was like, "Okay, Google," because she hear it a lot when we try to ask for questions and try to communicate with these conversational agents. Now, I mean, from this point, one also of the interesting questions that I have, and I have special interest in software engineering, is, well, do you think that we will witness a day where a natural language conversation can replace code? And from this point, also my question is about the balance between formal languages and natural language, and where you see like conversational agents going in terms of replacing code? Is it more, we will move more towards formal, more toward natural, and what's the sweet spot in this regard?
Well, that's not a, by any means, a trivial question. Let me give you two ideas related to that. I think the first is, I think we, in the last 20, but mostly in the last 10 years, we added a new way of doing code to our repertoire, which is basically the way machine learning works. And used to say to do the way to do code was, I mean, you tell step by step what the machine should do. And now I also can, for many problems, tell these are examples of you should recognize. These are patterns. These are, you code by examples. Okay. I mean, some of you may say, oh, but that's not so much different than some of the optimization stuff was in the past. And I probably, optimization and when you had very formal mathematical models somewhere in between. Okay. But I think we create a new way to talk. Unfortunately, both ways are very far from natural language. Okay. And so one of the things we're trying to do in the last piece of work there was actually a machine that could merge both ways. Suppose in this idea that you have this is still a case of recognizing classes, saying you could give examples or you could describe the class. Either in that work we try with written descriptions of the class and taxonomic descriptions. So in many ways, that's closer to how people actually think about classes, but still a far way. If you ask someone how you define the class of what's a cat, okay, and you try to generate code from what they answer, it'll be extremely hard at this point to do that. But I think it's a very important thing to do. I also think there's one thing. Thank you for a question, because I just realized there was one slide missing from this talk, which is I wanted to I would like to point you to a book that was recently published by, it's called The Art of the Software Arts by Warren Sack, which basically Warren is a guy who understands a lot of theoretical computer science, understands a lot of philosophy, and he basically, in this book, which is quite dense, in fact, he goes through this whole issue of software and makes the argument that software is in fact an act of translation. Okay, and when we think about that and say, okay, it's translation from what to what, and when we see that way, say, okay, I want to change my input language, but also a common way that we do is we change our output language in this process of translation. But one problem that he points, and I think is like any act of translation involves loss. And dealing with loss of this translation is one of the major difficulties with this whole enterprise, both in machine learning and in traditional programming. I mean, I'm probably not doing justice to the complexity of his argument, but I think the answer to this question is we should pause and say, what is this process of making a machine understanding what to do? And that depends both on the capabilities of understanding the machine and the capabilities of us to explain what the machine has to do, which is similar to any other human being, I mean, in many ways. Okay, so that's in some ways it's still a lot to understand and to discover. And I think there are fundamental blocks of AI which are not solved well. I mean, like planning, we still do planning like we are in the 80s. No, sorry if there's any AI planner here, but I have not seen anything similar to what we saw recently in similarity problems there. Okay.
Any questions? No.
So someone says that they think they can't properly create phrases when they talk to Google Siri. I was wondering what, Diego, what they mean by that. No, it's hard to talk. And it's interesting how we're still how Alexa and Siri sort of model Star Trek from the 60s in the way you interact with that. Okay, there's a whole, I think there is a Kai paper about that, which is looking, and it's so odd. It's so odd. I think that it's still imperative. It's still. Go ahead.
Sorry. We have like the last question from Rita.
Hi. Yeah, I was just, thinking about going back to the discussion where we were talking about how we design bots which are more human-like. So I'm thinking, and I want to know what your insights are, that if we are trying to design a bot and we have specialized instances for each task, such as, opinion mining or sentiment analysis, would that be useful, for example, to offer empathy and, deliver more human-like conversations? And I think that could be very helpful in any domain, but specifically for healthcare domains, for example, where patients are reaching out to, they are suffering from a disease and, they want to know that how they can deal with the pain, for example. So, just wanted to know what you think about it.
Well, there are two big issues in your question. The first is sentiment analysis, and I think that's a field which has deep problems in many ways. Okay, it starts with the whole Elkman classification of emotions, which, I mean, anyone in psychology think that thing doesn't make sense. If you read how that was produced, it has all kinds of methodological errors. Okay, it was designed for something else. So first thing is forget that field has to forget, say, Elkman. Say, if you use Elkman, reject it, automatic rejection. Okay, Elkman is about recognizing facial expressions and nothing else. So first thing. But when you see empathy becomes complicated with machines, because if a machine says, "I understand your pain," what that possibly means? Empathy is about it's often about I can put myself in your shoes, which is often extremely hard for human beings anyway to start with. But for a machine to say that, it's okay. At the same time, I think there is maybe empathy-loaded language that people may like to hear from machine. Okay, but again, using that right and avoiding that issue of, come on, machine, you don't know what pain is. Don't tell me that overheating is like pain. Overheating the CPU is not like pain. Okay, and in fact, I mean, it's very hard for human beings to say, I understand your pain. We don't know even if we feel the same pain. It's okay, so empathy becomes hard. I think right now what we can do is test, is we develop a bot and we see how users are reacting to it. But we have to be very careful because as I mentioned, the way people interact and what they expect from the bot changes as they use more. So I think often we do the mistake of we tested the first time users, the people as if they were the same. They are not. I think all we have seen, they are not. As you use more, you you use in different ways, you expect different ways. And often people will tolerate things just because they know that, okay, here comes that stupid bot pretending they know what my ping is because it's useful, but it shouldn't. So we need much better testing than we do now for bots. They are, and we know from, I mean, we as a field, we know that people develop all kinds of relationships with machines. I mean, starting with the whole Clifford Nass media equation. I mean, we know that people find all kinds of weird features in machine, and they read things. So right now we have no way out, just testing. Maybe, but we should publish and we should share more, and then maybe someone will be able to put this together and translate that into guidelines. But my feeling is they need to be temporal. They need to be temporal in the sense of the amount of experience of the user and how often the user deals with that bot.
Yeah, I mean, just to follow up to that, you know, in terms of software engineering, we were thinking about, you know, developing bots that could, you know, think about the well-being of the software engineers. And in the previous keynote, Paige mentioned, you know, that, you know, just like asking them to take enough breaks between work. So I think those things could be easy to implement, but I mean, how do you, you know, I was thinking about it, how do you like calculate or understand the well-being? I mean, there one possible way could be to do like an emotion profile of that person and see like, you know, where he or she is, because as I can remember, I remember seeing a complex chart of emotions, and, you know, there is, as you were saying, there is no consensus on like discrete emotion categories. It's like very, you know, even in there's the one that we know most often is the circumplex model of emotion, which has the you know, the 8 or discrete emotions on the axis of, and then there are more complex emotions between how it varies in terms of valence and arousal. So it's kind of very complex to correctly determine the particular emotion.
No, I totally agree, and I think if you look at specific, okay, you put a case. I want a bot that helps the programmers to not kill themselves, okay, of work. I mean, when to interrupt someone is a very complex and difficult question. And I mean, you don't interrupt people when they are in the flow. And then that psychological way of that's a disaster. That's the worst thing you can do. Okay, but sensing that, I mean, you're not good at it at this point. We cannot make machines sense those things well enough, I would say, to do. And at the same time, we have also the issues that the people who work in persuasive computing deal with. Is saying how interrupt, even if I want to suggest things, I mean, if I always do the same way, it becomes ineffective very quickly. So again, the thing is, it's still very hard for us to define the intent, and the action is also difficult. We have challenges in both sides. I mean, what we found in Chatbots is that intent, we became a little sort of good, some quote, good, okay, if you do enough engineering. But I think there's a situation which is very hard. I think in general, the more complex this domain, the harder to build a system, a language-based system which is effective. And we should be aware of that. It's easier to help someone who's doing generic, I want to schedule an appointment, I want to schedule a reservation in the restaurant, then I want to help a programmer to find cybersecurity issues in a code. Okay, that's my feeling, I think. And that's why we focus more in customer service, because we think in general there are much simpler tasks. If you look at what Google has just done in terms of releasing for duplex, they enable the voice system to screen calls for you, see if it's a person on the other side. I'm not sure you have seen this. You can do that with your Android phone now, and you can ask your system to hold in a line for waiting for your turn in a call center, which I think it's a beautiful paradox of two machines wasting time together, which is somehow tells us where we are in this whole mess of call centers, which in my view has the issue is we have to reinvent them. They don't make sense for machines. They make sense for large groups of human beings in a warehouse somewhere in India or in Sri Lanka or whatever. We have to reinvent the concept. But anyway, I think this is the difficult we are, but at the same time, I think there's so much to discover.
Thank you so much again, Claudio, for your excellent talk, keynote, and for the awesome discussions. Now we are going to move to Stefan.
Okay, thank you. Sorry for my internet connections, my internet connection trouble again. And thank you so much for inviting me.
Yeah.
So I have the honor to close our workshop today. I want also to take the opportunity to thank everybody who presented today and were here for the Q&A, especially our keynote speakers, Claudio and Paige, but of course all the other authors and presenters. But also everybody who participated and discussed with us, or maybe just listened in and tried to get a feeling of what's going on with bots and software engineering. And of course, I want to take the opportunity to thank everybody who helped in making this thing reality, especially my co-chairs, Marielle and Marco, but of course also, and very particularly, the proceedings chair, which also Marielle, but the web chair, Ahmad, the publicity chair, Marvin, and Caleb is not on the website, but he helped in with Zoom. Thanks, and also very warm thanks to all the members of the probing committee who helped us in reviewing the submissions and giving helpful feedback to all the authors. It was a very easy, seamless collaboration with everybody, and thanks for that. It was really nice. Want to say now here, for us, it's very, very important that this thing here is an open community and a friendly community. So if you're interested in working with us in any future possible incarnations of this workshop, just drop any of us an email, write to us on Twitter, wherever channel you want to choose, and say, yeah, I would be happy to help. I would be happy to be included in organizing something. We definitely are very much open to that and look forward to welcoming new people also in the organization. And for that, I would like to ask you, I mean, already people are leaving, and I'm very well can understand that. If you want to give us a reaction, because on Zoom we have this very nice reaction feature, and there's a yes and a no, and I want just to get an impression of you guys. Of course, you're biased, you're here, but also get to know how it went this year. Would you like to attend a BotSE 2022? Hopefully in person the next year. Thumbs up is also good. Okay. Quite a lot of people with thumbs up or a yes. Okay, cool. Thank you. Then I only want to mention again, Marco said it in the beginning, but we are very happy that we have this IEEE software special issue. The call for papers is not yet on the website, but will be soon. I hope the submission deadline will be probably sometime in autumn, and the papers will be published next year. So there's some time to work on something, but we would be really delighted if we get a lot of submissions from the community here and see all your great papers for the special issue. But of course, it seems we will try to have a BotSE 2022, and the steering committee, we established a steering committee last year to maybe continue that in the future. We'll meet also later this month, and we try to make a plan for next year then. Anything else you want to bring up? Anything we can improve on the workshop, or any feedback you have for us? Oh yeah, recordings. Thanks, Niels. Niels, that's a good point. We will put the recording on YouTube. The link, I think Marvin already twittered the link, so it's on Twitter, but we will also put it on a website. So you will be able to access the videos where we have the permission of the authors to put on YouTube. You will see them there too. Okay, cool. I don't see any other comments. Then I think the only thing left to say is have a very nice weekend, and I hope to see you next year in person again, and then we can have a nice dinner and maybe a beer or wine or whatever together. Thanks, everybody.